Right, good morning to you all. We've reached 10 o'clock and so time to start. So welcome to the International Manufacturing Forum Series 2021. As I hope you know, this is a year-long conference in which each month there is a one-day session on a topic drawn from the broad field of manufacturing. And this month, the topic is COVID-19 and manufacturing. And this is obviously, the pandemic has changed the world in ways that we didn't anticipate, with over 100 million cases of infection. And of course, we should reflect on the human toll of more than 2.25 million people who've died as a result of the virus. And but out of all of this trial and turmoil has come lots of examples of the ingenuity of scientists and engineers to develop new ideas and new approaches to the process of protection or instrumentation or facilities. And so that's the topic of today. But before we start, we can welcome the President of the Polytechnic of Leiria to make some welcome comments.
Hi all, it's a great pleasure as President of the Polytechnic of Leiria to be here in this welcome session on the Virtual International Manufacturing Forum Series 2021. Of course, I want to greet all of you, but also I want to greet the chair of the conference, Professor Jeffrey Mitchell, as well all the integrated members of the Center of Rapid and Sustainable Product Development, the CDRSP, including, of course, the director, Professor Nuno Alves. This is a unique event. It's a huge opportunity to discuss the direct and digital manufacturing. In fact, during the whole the year of 2021, we will discuss every month one specific topic that we will share to all of you and with all of the world. In fact, we will go to this idea to put together COVID-19 and manufacturing. In fact, for us, for the Polytechnic of Leiria, but also for sure for the CDRSP, this is a unique and pioneer event because it's a true open science strategy connected to open and free for all the participants. But I really hope that this outstanding series could be recorded and shared with all the world, not only through the higher education institutions and research units, but also with the companies that are connected with this topic, this outstanding topic of the direct digital manufacturing. Please enjoy all the event during this year of 2021. Thank you for all of you, for all the shares of the conference to participate and to disseminate research with impact to society. Thank you.
Right, thank you, Rui. So this session today is on COVID-19 and manufacturing, and the chairs of this particular session are myself and Artur Mateus from CDRSP. If you participated last month, you will know one of the features of each of these sessions is that on each day we will have we collectively, the audience will vote for the best presentation of the day, and at some point Renato will paste into the chat part of Zoom a link to go to a web page where you can select your particular favorite presentation. Of course, I urge you to wait to the end so you've heard all of them. Right, so we make a start, and it's a great pleasure to welcome Dr. Patel from the Central Scientific Instrumentation Organization in Chandakar in northern India to talk to us today. Dr. Patel is a bit of a celebrity in India in that he's last year received some prizes for the Young Scientist Award and also some invention awards. And so it's a great pleasure to invite him to take the floor to present his lecture on a time with electrostatically charged sprays for the mitigation of COVID-19. Please.
Yeah, thank you, Dr. Michel, for introducing me. Yeah, good morning to all. Though it's in India, it's a time around 4 o'clock, 3:35. So very good evening and also very good morning for you all. So I'm sharing my PPT for today's presentation. So hope it is visible to all. Is it okay?
Yeah, it's great.
Yeah,
Yes.
Am I audible?
Yes, yes, indeed.
Yeah. Okay, thank you. So today's topic is around basically will be around COVID-19 and manufacturing. So it's a great topic that has been chosen during this pandemic, as he has mentioned in the you can say opening remarks, that it has changed the life. You can say it has taught us how to live with minimum requirement. You all are earning, and we all say that there should be some this much money or something like that. We live a leisure life, okay? But it has also taught what are the minimum requirement to live a life, okay? During lockdown or something, when you are closed in your room or your home. So what are the requirements, minimum requirements? So it has taught us related to them. So I will present basically some technological development that we have worked and developed this technology for the mitigation of you can say COVID-19, basically to spread the coronavirus. So it's a sanitizing equipment based on electrostatic principle, and so this technology is known for the long time, but for mitigation of you can say COVID-19, it's a unique kind of experience. And also so let me introduce my institute, because there are some audience from some different countries. So I'm working in Central Scientific Instruments Organization, Chandigarh. That is a constituent laboratory of CSIR. 38 labs are existing with this CSIR system, and CSIR, as per the Nature ranking, it ranks first in India and also 12th ranking among government institutions worldwide. So it's a very reputed, you can say, institution which is working on different kinds of areas like biological, engineering, material, chemical, sea kind of national, you can say, Institute for Oceanic Research, etc., etc. So it is basically for societal and industrial problems, solving the societal and industrial problem. So CSIR is meant for that. In India, there are various research institutions. For example, ISRO. ISRO is meant for space research. DRDO is meant for defense research. CSIR, in the same way, is meant for societal and industrial problems. So once this corona came in India around first week of or second week of March, although its origination came around 12th February from Wuhan, China. But in India, it came around 19th Feb, first case or something like that. Okay, so this is how about our institute. It is situated in northern part of India, basically very nearby Delhi region. So CSIR, CSIO is divided in different kinds of department, that is agronomics, biomedical engineering, optical devices and systems, advanced material and sensor, precision mechanical systems. These are the vertical, means there are major departments, and to support these major departments, there are other departments, supporting departments, that is called horizontals. For example, computational instrumentation, ubiquitous analytical techniques, that is majorly for analytical research based on nanotechnology and nanoscience. So this is our department, and let me give you a brief about research activities going on at CSIO Chandigarh. Basically, we work on two fronts, that is research and development, and next one is academic institutions. So we have two academic institutions, one is for higher studies and one is for diploma level certification providing. Basically nowadays it is a skill development department that is run by Swiss, with the help of, in collaboration with Swiss government. So higher institution is Academy of Scientific and Innovative Research, that is for MEMTech, MTech and PhD degrees. And Indo-Swiss Training Center majorly provides diploma degree. So in research part, we work on societal problems, we work on high science, we work on strategic sector. Head-up display, that is you can say Tejas aircraft, that is designed by CSI India, that is a fighter aircraft in which there is a head-up display which pilots sees and fly the aircraft. That is designed by CSIO only. And today, let me you can just inform you, there is a Aero India show in Bangalore, and this aircraft has been flown, and our head-up display is there. So our one of department, that is a optical division, is working on head-up display. Another technologies that we have developed on agro field, health sector, public safety, and human resource development. So these are the few technologies that in recent past we have developed, that is electrostatic based technologies applicable to agriculture, environment, food safety and nutrition, disinfection. One of forte is head-up display, that is put on you can say on all kind of aircrafts, fighter aircrafts which are used in India. Even we are the fourth country to develop such kind of you can say head-up displays worldwide. Another devices, that is biomedical division, working on 3D printing for biomedical implants, prosthetic devices. Maybe you can say there are some technologies based on some eye gesture movement to control the patient vehicles and all. So these are the few technologies that we have developed in recent past. One more device is that Diffusion, that is for blind people, that is to convert the text into speech signals. So that is a name that has been named as Diffusion for blind people. So these are the few technologies that our institute has developed in recent 4 to 5 years. Now I'm coming to the actual topic, that is today's topic of presentation, that electrostatic spraying technologies and its varied applications, including disinfection device. So electrostatic spraying is one of the most efficient and effective methods to apply the liquid-based solution, either be it a agriculture pesticide or be it a disinfectant, be it a smoke control, that is usually we spray the water mixed with some disinfectant solutions, or you can say surfactant solutions to suppress the dust so that it cannot create a smog. which is usually nowadays Indian cities are facing. That is, smog problem is too much in Indian cities, and we are facing a very challenging task to suppress that dust so that the smog cannot hindrance all the kinds of work or flights or maybe normal life also. So it has application in agriculture, environment, medical and health, that is disinfection device, sensors and system. Dr. Mitchell is working on these kind of systems for a long time, that is electrostatic deposition techniques or electrospinning or some sensor applications. So he is well aware of it. Food safety and nutrition, basically nowadays, very recent project is there. We are developing some electrostatic coating system for fruits and vegetables to enhance the shelf life and also nutritional value. Our purpose is to enhance the nutritional value so that eat less and you will get more nutritional value. So because the population is growing, there is a huge demand of, you can say, processed food and healthy food also. And another application of water energy, that is, you all know that electrostatic precipitation technology can be used for, you can say, air purification as well as water purifications. And these are the few applications that we have covered, almost 5 to 6 applications: agriculture, environment, medical, sensors and system, food safety and nutrition. That's 5 applications we have covered, and we have not entered yet on energy and automobile industry. So in coming days, we will working. So the question is, what is electrostatic spraying? Okay, electrostatic spraying, where we put one electrode and this spray is coming out of this nozzle. Basically, it charges the droplets. Okay, by charging the droplets, basically you are able to control the trajectory. You can say you can deposit as per your requirement, whatever the application is. Okay, so let me just explain. There are various kinds of method to charge the liquid sprays. That is ionized field charging, conduction charging, induction charging, triboelectric charging. So depending on the application, you choose the charging mechanism. For example, in agriculture, induction charging is one of the most efficient method. In you can say sensor sign system, basically for in electrospinning, there is a corona based charging or conduction charging is used. So these are the few mechanism to charge the liquid sprays. One is induction, conduction, corona, and field induced charging. So these are the various methods to charge the liquid sprays. So what happens in induction charging, one charged body comes nearby some, you can say, uncharged body. So it polarizes the charge. So when it polarizes the charge and it go the charged body goes away from that object, it again gets neutralized. So what happens when it polarizes? One kind of charge you have to extract from that body. Okay, if you extract either positive or negative, another opposite charge will remain there, and ultimately that droplets will be charged in that kind of, you can say, polarity. That droplet will be charged negatively or positively. So you have to extract one kind of charge by grounding it or whatever the mechanism you adopt, but grounding is the basic phenomena. So one portion should be on high voltage electrode and another portion should be on, you can say, water based solutions. So it will charge negatively. So this is the principle of negative, you can say, negatively induction charging. So these are the few phenomena, and these are the equations governing how much charge you have provided and what is the maximum charge limit on those droplets. Okay, so basically when you charge, you are able to govern the trajectory of that charged particles. Okay, so one bigger smaller dissociate into smaller droplets. When you provide a charge to some certain bigger droplets, once you can say one limit comes when surface tension forces are disbalanced, disturbed by electrostatic forces. And once the electrostatic forces are more, or you can say overcome the surface tension force, it dissociate into smaller droplets. So one bigger droplets dissociate into smaller droplets. So this is the how electrostatic phenomena, and smaller droplets are more efficient to take charge rather than bigger droplets. So smaller droplets carries more charge. So once you charge and droplets coming out of the nozzle, there are various forces act on that, you can say, charge droplets. It's a frictional force, it's a, you can say, buoyancy force, it's a gravitational force, electrostatic force, and basically you are overcoming the gravitational forces by electrostatic forces. This is how you charge, and this is why you charge the droplets, because you want to govern the overcome the gravitational forces. That is a major drawback of electrostatic spraying, to waste the material. Okay, due to gravitational force, the material goes onto the soil, or you can say in case of agriculture or disinfectant, it goes to off target. So you reduce the losses by, you can say, providing the charge to droplets, and you can say you are controlling the mechanism, trajectory of those charge droplets. So these are the different forces when charge droplets travel into aerodynamic collision. When you design a nozzle, there are various parameters. So to design, you can say, to optimize. There is a, if you talk about air-assisted nozzle, there is a one parameter: liquid flow rate, applied air pressure, applied high voltage, charge to mass ratio, how much charge you have provided to that droplets, load current, how much current is it drawing from the source. That is basically when you come to a design of high voltage power supply to charge these liquid sprays, how much voltage you are applying to electrodes. So you have to design a high voltage unit or circuitry to supply the voltage. In that case, load current, how much load current you are drawing from the source, it is one of the most important factor in electrostatic spraying. Resistivity range, when you design some system, it should be able to spray all the liquid or all the conductive liquids or resistive liquids with the same system. So you design in that way, or you set a charge to mass ratio in that level, so that any type of liquid can be sprayed, either it is less conductive or more conductive. Because for example, in agriculture spraying, farmers doesn't know that what is the conductivity and all. You have to set a certain threshold of charge to mass ratio. When it sprays, that charge to mass ratio doesn't come to that threshold value. Okay, so one of the parameter in designing the system is conductivity of the liquid. There are surface tension, density, other parameters are also there, but the major parameter is conductivity in case of agricultural spraying or disinfectant or disinfection machine. Deposition is similar. These are some performance parameter. Uniformity coefficient, droplet size. Let me just explain what is the importance of droplet size. In next slide, I will explain. In charging, there is one more parameter during the design. I am talking about design parameters. There is one electrode material. Depending on the application, you can change the electrode material. But in previous cases or in literature, it is available that only copper or stainless steel or brass, you can say brass material has been used for designing the electrode, charging electrode. But in very recently, we have published one paper, and we have used nickel in case of, especially in case of agricultural spraying. We have used nickel material to design to use as a charging electrode material. And charging, because it provides more free electrons at the surface of this material, so that it can transfer more charge onto the water droplets. So nickel is one of the most useful material for charging electrodes. But in case of food safety or nutrition, it has to be examined that it is toxic or not. So it cannot be used everywhere. But in case of agricultural, because nickel is assumed as an inert material, so nickel can be used as a charging electrode material in agricultural as well as disinfection kind of machines, but not exactly on food safety, that electrostatic coating system for fruits and vegetables, where you are spraying edible materials. So edible materials cannot be, you can say, nickel is not useful in that case. So this is the importance of electrode materials for charging of liquid sprays. So when you design, there are various parameters. One is a power supply, one is a electrode material, and one is some performance parameter. So in next slide, I will be explaining. So in droplet size is one of the most, you can say, important parameter, and it can vary with the application. For example, in agriculture, there is some another size, you can say 30 to 40 micron droplet size is more, you can say, suitable for in agriculture. But in the same case, in disinfection, you cannot use those sprayer or agricultural sprayer for spraying the disinfection. In case of disinfection, the droplet size should be you can say lower than agricultural sprayer. So these are the droplet. We have played with these droplet size by varying different kinds, different air pressure as well as high voltage. So you just see the example of different types of sprayers, that is agricultural sprayers, you can say air assisted nozzles, motorized as well as manual. So you just see in case of agricultural spraying, the droplet size is too big. And when corona this pandemic came, all the agricultural sprayers are employed in disinfection purposes. So there is a huge you can say chemical load in the environment. Okay, now all the agriculture sprays are spraying huge amount of hypochlorite, H2O2 and other disinfectant materials like agriculture pesticides are used. So there should be some, you can say, there should be some requirement of efficient kind of disinfectant devices. And we thought that we can design electrostatic disinfection spraying systems to spray especially for disinfectant and sanitizing material. So you see this figure, you will find we can generate 5 micron, 7 micron, or even 20, 21 something micron droplets by varying the air pressure as well as the high voltage power supply. So we can play with the droplet size, and we can you can say specific to some application like agriculture or food safety or environment dust suppression, etc., etc. So this is the system that we have designed, that is air assisted nozzle. And the beauty of this nozzle is that it is well published. Even it is a electrode material, it is a power supply, it's a air pressure electric switch, because this system contains high voltage power supply as well as a air pressure electric switch. Air pressure electric switch basically used to switch on or switch off the high voltage power supply to make it automatic, otherwise it will harm, because there is a voltage around you can say 1200 or 1300 volts, and it can make a shock to anyone who is using this nozzle. So you have to make automatic based on air pressure applied to this nozzle. The high voltage gets switch on or switch off. So it's an automatic kind of system. So but some more clear picture of that design is we have a US patent on this system. So these are the few technologies that we have developed in the recent past based on electrostatic spraying, that is electrostatic pesticide sprayer. Another is electrostatic disinfection machine, that is a very recent development during corona crisis. Dust mitigation and snot control device. In India, there is a huge you can say demolition and construction takes place. So there is a generation of dust in most of the parts of northern India and coal mines, cement enterprises. So we need to suppress those dust at the origin level. Otherwise, it is creating smog once it is going up and mixed with smog. So it is creating smog. So we have designed this such kind of system which is generating water droplets of carrying some charge. So charge droplets are more prone to suppress the particulate matter. Another system, electrostatic coating system, that is our running project, and we are working on this basically to coat the edible coatings, edible like aloe vera or some other material on fruits and vegetables to enhance the shelf life. You can store for more time, as well as we are spraying some nutritional kind of innovative solutions to those apples or you can say any fruits and vegetables to enhance the shelf life as well as nutritional value and sensory attributes. It cannot change ultra or some nutritional value of that product, as well as we are adding the nutritional value by such spraying system. These are the two additional technology, that is air pressure electric switch and high voltage power supply, which is used in these all the technologies. So we have designed indigenously here only. So no component in this device is procured or you can say purchased from other places. So another technology is that we have developed, that is an aerial spraying system for locust control. In India, every year there is a huge attack by locust worm, which is coming from African countries, and then I can say Iran, Iraq, Afghanistan, Pakistan, and then enters into India. Okay, so in this year, it was a huge loss of crop due to this locust worm control. And at that time, some governmental decision took place that we can buy some aerial spraying system for, you can say, United Kingdom. And they have done some, you can say, signing of MOU and all. But they have said that they will supply those system maybe in November or December. And that was the peak time at May and June. So with the help of Indian Air Force, we have developed this aerial spraying system in which air-assisted nozzles are there, which can spray malathion or another, you can say, chemicals in to control the locust worm in Indian, you can say, agricultural farm. And another system that I am working on, drones as well as robotic systems, that is for precision agriculture, you can say in one term. But we want to combine actions of robotics and drones simultaneously to, you can say, achieve some kind of agricultural task as well as some other task. So there are some limitations of robotics as well as a drone. Drone has some limitation and robotics has some limitation. And by combining both the things, let me give you some example. If you are assessing some damage of crop or something like that, you can use the drones. But drones cannot be used for spraying too much, the huge pesticide or carrying some activity. So drone can, so robotics can, autonomous system can do that. So we are combining both the, you can say, activities to make it more suitable for Indian agriculture. So this is the first technology that we have developed, agricultural sprayer. I will not go into details. This is the slide that I just see. The Dr. Mitchell is there. He was the convener of that conference at that time. Okay, so I met him in Manchester. This has made us to come together to work on some research problems. So last year in 2019, we met in Manchester. So at that time, in that conference, I have presented some work on, you can say, biopesticides, or you can say herbal pesticides. Basically, chemicals are getting depleted slowly. So we thought that our nozzle should be, you can say, able to spray the herbal pesticides, or you can say biopesticides also. We made that nozzle suitable to spray these such kind of, you can say, bio or herbal pesticides. So this work I have presented in Manchester. So I'm coming into the exact topic that today we are going to talk about, that is a COVID-19 and manufacturing. When in India, it came around, you can say, March, second week of March, but first case was observed, detected in China on February 12th, 2019. And then till now, almost 104 million people has been, you can say, affected, and deaths are 2.27, which is has occurred in United States. That is the most cases has been found, and then followed by India, Brazil, United Kingdom, and Russia. But the good thing is that we have made the vaccines. Two vaccines are right now in India are going to are in production, and we have supplied, you can say, India has supplied vaccines to other countries also, like Brazil, South African countries, and also some European countries. So yeah, we have developed that vaccine. But I am coming to the topic that we have developed electrostatic disinfection machine suitable to spray the disinfectant and sanitizing materials. And we have conducted the study how it is responding to any surface, how much it is surviving in surfaces that daily to daily life you are coming into contact, like metal, wood, paper, plastic, rubber, ceramics, and gloves. Every day you are coming into contact with some kind of material, and when viruses or pathogens are, how much they are surviving after spraying hypochlorite, or you can say sodium hypochlorite, ethanol, 2-propanol, sodium hydrogen peroxide, formaldehyde. There are some sanitizing materials. So how much percentage you have to spray, how much it survive on the some different kinds of surfaces, and we have conducted. So this is the device that we have developed, and these are the some properties which is required during the design. Basically, what happens in conventional sprayers, you use some kind of whipping kind of or some conventional methods, and in those conventional method, it is not the disinfectant or any sanitizing material, is it not reaching underside of the, you can say, table, chair, or some hidden areas. But by electrostatic spraying, you can cover 360-degree coverage because of its property of, you can say, it will travel in electric field lines. Any charged particles travel in, you can say, their field lines, electric field lines. So it covers 360 coverage. So it reaches any hidden areas as well as, you can say, uniformly deposition. So material loss is very less. So we have developed this technology, and at a later stage, it has gone to industry. It has a huge application in India. There is a too much requirement of those systems, like in workplaces, offices, hotels and catering, airports, railways, fruits and vegetables can also be disinfected, poultry, public transport, healthcare. So there is a huge requirement of such kind of system. So we have developed and we have transferred these technologies to various industries, including Bharat Electrical, that is a PSU of Indian government. So these are the some, you can say, properties, or you can say advantages of this, that spraying system. That is, it is efficient, uniform deposition, it covers underside of the target as well as any hidden areas. Droplet size is incomparable to the pathogens or viruses, so it can kill the viruses or pathogen very effectively and efficiently. So these are the some studies that we have conducted. That is, we have taken some kind of E. coli, bacteriophage, preferences, and some, you can say, pathogens, and we have sprayed and studied that how much volume it is reduced in comparison to conventional sprayers. What are the off-targeted losses are there. So we have conducted these studies, and we will be publishing very, you can say, in few days, you can say in next few months, we will communicating this work. So I cannot disclose too much on that study. Basically, we have taken 5 to 7 disinfectant material, and we have taken 8 to 9 surfaces, and we are spraying with electrostatic spraying and studying that how much that pathogen or virus can survive on that particular surface. Right? There is a wood, paper, glass, plastic, rubber, etc., etc. So these are the 3 brand name, or you can say product that is available in market. So these are the worldwide scenario. Basically, in this field, only some USA systems are available. That is Clorox, eMist, and Victory, or you can say Max Charge. So these are the some comparative study that what they are using, how much voltage are they are using, what are the electrode material, what is the cost, what is the technology, either it is patented or not. This is some comparative study available. So during the corona crisis, let me clear you one very important part in where this technology uses, that is air pressure electric switch. During the corona crisis, previously our companies were procuring this switch from USA, that is Numedine, and during the corona it was stopped. Basically, there is no export and import at that time, so they have denied to you can say supply that pressure switch. So we have worked on that pressure switch, and we have made it within few days with the help of industry. So now it is totally indigenous technology which we have developed. So these are the few startups that this work has created. There are 3 startups have been created, and they are doing well, good in the market. So this is the reachability on in all over India, as well as nowadays it is getting exported by few of our technology partners. So I'm coming to some another interesting application So how we have observed this and how we came to, you can say, came to this, that how it works for dust suppression. Basically, when you spray, the charge droplets travel some distance. Okay, when it travels some distance, it gets neutralizes. Meaning is that in environment there is some charge is present. When you spray, either it is positive or negative, it recombined with that charge droplets and gets neutralized. So in the same way, we tried it to suppress the dust. This dust slowly go up and gets partially charged. And either meaning is that particulate matter gets partially charged when it goes up. So when you spray the liquid only without any charge, it is not able to come into contact with that dust and it cannot suppress efficiently. But if you once you charge these droplets and you reduce the size, it interacts more with the dust and it suppresses very efficiently. Okay, so these are the few another technology that we have developed very recent past, and it is used in Delhi and other metro cities to suppress the dust, and we have to get rid of that, you can say, smog problem in India. Otherwise it is getting worse and worse every day. In line to that environmental pollution, we are going to work on, you can say, we have started working on air electrostatic precipitation technology. It's a well established in some European country, but in India there is no manufacturer of electrostatic precipitation technology, and we are trying to work on those technologies to purify the air, you can say. So another technology, that is food and safety and nutrition, that I have indicated in the previous slides, that we are developing some coating system to coat the fruits and vegetables to enhance the shelf life. Basically, it produces a uniform droplets. So when you deposit some fruits or vegetables or some edible coating, it coats the uniformly. Okay, in dip coating, you dip that apple or even any fruits, and it accumulates some material on underside of that object. But in case of electrostatic, it is uniform deposition. Okay, so this is another technology, and we are characterizing such systems by characterizing pH, TSS, firmness, weight loss, and some shelf life calculation. So we are working in such systems. I will skip in this. I will also skip because this is not, you can say, exactly matching. Yes, Dr. Mitchell is working on the rapid prototyping or 3D printing. Just a throw on that CSIO is already working on 3D printing for, you can say, bioimplants or implants or human implants. We are thinking why we can't use electrostatic on charging of some such metal type of solutions in which 3D printing uses. So can we do that? We have to look into these, you can say, possibilities in coming time. So yes, I'm working on drones and UAVs also. So this is my team in CSIO that we are working. I have a PhD scholars, I have a project staff, and some mentoring team is always there to, you can say, help me during my, you can say, research work. So presently I'm working with some foreign universities like Modo University, Police Academy of Sciences, University of Florida. That is very recently we have got one project under IUSSTF that is for to develop electrostatic disinfection technology and to launch it in the USA counterpart. So these are the few technology recent activities that I'm going to work, and I will be working on these technologies and research activities. So thank you so much, and thank you so much for listening me. And now we have question answer. So you are most welcome to ask the question. Thank you.
Right. Thank you very much for a very informative and interesting lecture. So we now have 10 minutes for questions, and I wonder if I could perhaps start with a question which is very relevant to COVID-19. You described some electrostatic spraying systems for killing the virus in working premises or in hospitals or all that. I wondered if there was any data that had been collected which shows whether the rate of transmission amongst people who work in these environments is reduced because of this electrostatic spraying. I mean, you showed that it killed the virus, but does it have a large impact upon the transmission of the virus from infected people to non-infected people? I mean, we can imagine it would. I just wondered if you collected any data on this.
Exactly. Yeah, I have not worked on virus. Okay.
Yes.
We are working on some, you can say, similar pathogens, or you can say viruses, but not exactly COVID, you can say coronavirus. Okay. Another labs in CSIR system, that is IGIB, that is in IIT Delhi, as well as CCMB Hyderabad. Both labs are working on same system, and that they are studying some kind of how it is affecting, you can say, in environment, how it is survives in the environment. And
Yes, yes.
so there is a study available and it is published very you can say it is. I will send you the link of that
Yes.
paper or scientific study, and that study itself you can say initiated by Director General CSIR with the help of Anurag Agrawal from Director IGIB. So that study has been going. One more study is going, that how much Indian population has been you can say you can say how much population has been affected. So there is a random samples has been taken, and that has been taken, that how antibodies had been developed or not. So almost you can say in Delhi 60% population has been affected, and all over India almost 45 of 42 to 45 population has been generated antibodies of that. Yeah.
Okay, thank you. So, other questions or comments? Probably the easiest way could be to raise your hand if you have a question.
It seems
well, your talk was very comprehensive.
yeah.
Could you identify if there's particular areas where, let's say, additional development which could take the technology to
That's why I have given some.
Other areas, you know, where it could be perhaps the process could be made more efficient or more effective in some way.
Just I wanted to ask you only in the between the lecture I had just pointed out, can we use electrostatic phenomena in 3D printing?
Well, there are methods of 3D printing using electrostatic techniques. Artur, do you know anything about these?
Using spraying.
Yes.
Not exactly, not spraying, but can be charged in the form of it will be solid, or it is a liquid form, or it is in powder form, or something like that. Can we use electrostatic phenomena in 3D printing?
Yes.
Because ultimately we are depositing some kind of in the form of solid or spray. Okay, so that spray can be charged, or maybe it will give a more you can say uniformity or governing some trajectory of that particles and coming out of that.
Yeah.
So
there
we
are
just
some selective powder deposition strategies using electrostatic devices for deposition of several powders in the same layer, but with different materials. Yeah.
Okay, Dr. Michel, that we are trying to collaborate, I guess, in coming time. And India has a very good department of biomedical implants. Okay, so they
Yes.
have these facilities of 3D printing. Right now, they have uh, developed the facilities, but nowadays they are working on some research problems also. So I am also a part of that team. Okay,
Yes,
so
yes.
let us plan some kind of, you can say, problems that we can work together.
Yes, no, that sounds very good.
Yeah. So I guess there is no
So
question.
anybody have any?
Yeah.
Yeah,
Mr. Patel,
Joanna.
I will send you a message sharing a system like I mentioned.
Yeah, yes,
Because could be a good thing to think about in you have a lot of experience in electrostatic as we see, and we have some experience in 3D printing. So I will send a link just you to read and then we will talk. Okay.
right, right.
Thank you very much.
Thank you
Yes,
so much.
Joanna.
My question is about the applying of the spraying in the material, in the fibers that we are building a protective equipment like a mask. We are developing some systems with a cellulose partner and fiber partner to coat and to change the properties in the different layers of the mask. And in this case, is to be applied in the material, in the different layers of the
Yeah, right. Nowadays there are masks which is having some you can say piezoelectric kind of material or different kinds of layer that itself generates high voltage and charges those some you can say when you breathe some you can say virus or something coming, it gets automatically filtered out. So some piezoelectric kind of materials are coming that is itself embedded in that you can say mask is made of those materials. So yes, electrostatic phenomena is useful in you can say mask is itself made by some piezoelectric material and which acts as a charging material.
But for protective materials, we have a lot of challenges like safety, because you are breathing. In this case, if you put it in a mask, you are going to breathe the active components that you put there. So there will
So yeah, I guess you are asking about we are spraying that those disinfectant to mask and also it is safe or not, right?
Yes, because I'm thinking about two steps. One, to disinfect before applying or to have a safe mask. One step that will be disinfection before using it, and the other step will be to add biomolecules that will have anti-biological effects, but that will be safe for you to breathe. I will present them coming from a plant in the afternoon if you want to hear about it. But the technique.
Dr. Mitchell, can you answer this question? Actually, I was also not able to understand also.
Oh, okay.
So I think the question is, if we make fabric,
yes,
a fabric like a mask or other fabric for other protective equipment. I mean, it could be, I guess, whole body shielding. Then have you had any experience of using electrostatic spraying onto fabrics to provide a clean starting point? And
yeah, I got it.
Yes.
Actually,
that was the question. Thank you.
Right. Actually, we are conducting right now these experiments where we are spraying disinfectant to various kinds of, you can say, metal, wood, fabrics, plastic, rubber, etc. And we are studying the time how much virus or pathogen is surviving on that surface, and that virus can survive from within second to 9 days also. Okay, but we have not yet published, so I cannot, you can say, we cannot discuss too much. But yes, we are doing that. we are working on that study.
Thank you.
Thank you so
Thank
much.
Yes. Thanks for the question.
Yeah.
Other questions?
So if there is, I guess, no question, so we can move ahead.
Yes, I'm just wanting
Yeah,
to make sure everybody has an opportunity
Yeah.
to ask, since it's an unusual experience to have
Congratulations.
you with us. So that thank you very much for the questions and discussion, and thank you very much for taking the time to be with us today, and we appreciate that. And perhaps you won't necessarily be able to be with us the whole of the day, because we're just starting and you're coming to an end, but thank you very much.
I will be there, so I will be listening others speakers
Yes.
up, so no problem. Okay, thank you.
Just take the opportunity, since we have a couple of minutes, to remind or to let those people who joined the conference later, that in the International Manufacturing Forum series, there is a vote, and so at the end of today, you will be able to vote for what you think is the best presentation in today's session. If you were present in January, then you might like to know that Dan Luer was awarded the best presentation certificate. So I think now we will have a short comfort break, and we will restart at 11:25.
Okay, coffee break.
Yes. Yes.
Thank you so much.
Yes. Yes. Okay. Right. Thanks. And we will then start with the second session, and Arthur will be the chair of that session. Right. Yes. Renato, could I remind you about putting the link for the poll in the chat? I mean, it doesn't need to be done now. Maybe after lunch.
Okay.
Yes.
Yeah. After lunch, I will include it.
Yeah. Okay. Many thanks.
Okay. Many thanks too.
Okay.
I've just muted Joanna.
Okay. Okay.
That's very difficult to do.
Let's start. I hope that you drink a good coffee. Here in my house, I ran out of coffee, so I didn't drink coffee. You are drinking coffee. So let's go to section 2. Now we go to hear about an important topic. It's not focus on a special, I think, specific technology, but it's something that happens also around the world. And here, for instance, in Marinha Grande, that we have a lot of companies focused in automotive, those things. We also experience the repurposing of these small business and other business. So this is an important topic in the world, in Europe, in Portugal. And I need to give welcome to Dr. Tariq Massoud. He is from the Department of Design, Manufacturing and Engineering Management of University of Strathclyde, I think that is this way, in Glasgow. Dr. Tariq Massoud works at Engineering Design Center and Institute for Manufacturing, while working with a number of industrial policy and academic collaborators on global changes across design, development, and service life cycles of smart product systems, assets, and processes. He has also interest group, a champion at the Cambridge Global Challenges Research Initiative, where his focus is global challenges, particularly on the interface of Industry 4.0 technologies and disaster management operations. The topic is COVID-19 and manufacturing, the power of repurposing factories. So please, Dr. Tariq, you could start.
Doctor, you have to unmute the microphone.
Sorry, first of all, thank you very much for your kind introduction. And hello, everyone. My name is Tariq Massoud, and I'm a reader at Department of Design, Manufacturing and Engineering Management at University of Strathclyde, Glasgow. And I'm very pleased to be able to talk to you all today. And particularly thanks to the organizers for inviting me to deliver this keynote lecture as part of the IMF 2021. The topic of my talk is COVID-19 and manufacturing, the power of repurposing factories. It's a very timely topic. While many of us are under lockdown due to COVID-19, the work I'm presenting here was done at University of Cambridge. So this is a broad topic, and it could mean different things to different people. So let's think for a moment about what we want to achieve from this talk today. So I've put this aim for this talk to explore how manufacturing has come up to the challenges of COVID-19, particularly by repurposing factories. And by doing this, we are talking about three main categories. Obviously, the factory is in the main central space while we are facing COVID-19, which is mainly about how we can tackle it, how we can manage the disaster, while factory is about making things and how we can meet the surging demands and so on. While on the other hand, just before COVID-19 happened, the Industry 4 drive was up on the gear, and where we were anticipating and looking at adopting new technologies and so on. So how these three things come together is an interesting question, and particularly how we can build resilience to disruptions by using these three lenses, because achieving resilience in manufacturing and the wider supply networks is crucial during pandemics. The following questions are important in this way. So let's think about these research questions that could provide a framework for today's talk. Though coverage would be at an overview level, but I will go into more detail for a few of these. But the main thing, first of all, is about how Industry 4 technologies could be better used for tackling and building resilience to pandemics. And particularly looking at different technologies and how they can help. And the second thing is about repurposing factories. And I will talk about a particular example here, how we can use robotics, whether those could help in repurposing factories, so that the production could also be ramped up in terms of different key critical products that we need, or systems that we need. For example, the ventilators and other PPE. And that will let us think about the questions of how and what are the characteristics going forward in terms of changeable, smart, or digital, or intelligent factories of the future. Because these things can happen in the future as well. So before going forward, I would like to talk about what was happening before COVID-19. So there were talks about crisis. There were specific communities who were discussing about how to manage the crisis. Obviously, there are organizations at international, national, and local levels who go through all the cycle in terms of response, recovery, and managing the disasters and preparing for the next one. But there were lots of people, millions of people were affected, and that was the trend was on the rising. Most tsunamis were happening, earthquakes, floods, and so on. Heat waves were happening, and so on. But the interest in terms of the research was not that great. There was some research in particular communities, but they were kind of working in silos. But on that note, at that time, we did an EPSRC Global Challenges Research Fund project in 2016-17, where we invited people from different places, particularly from South Asia, and China, and Turkey and US and so on, and from the UK, to discuss about how we can think about different disasters and whether different technologies can help in terms of tackling the crisis, particularly looking into the earthquakes, floods, and disease outbreaks, in which we looked into tackling dengue outbreak in Pakistan using technology. So that the effect could be mitigated or maintained in a particular situation in that way. And what we found was that as the most of the disaster management organizations, they go through response, recovery, mitigation, and preparedness phases whenever they tackle disaster. So at the moment, we are at response or recovery stage for the COVID-19. But most of the mitigation and preparedness phases, they come later on. And the preparedness phase is particularly at a normal time when we are not facing disaster. So we think about these later two stages when we are in a normal state. So we built a resilience framework which provided a stepwise process to look into and develop resilience when we are at peace. So this was, we called it DROPS model, where the organizations, the companies, the manufacturing organizations, the supply chains and others, the international, national and local organizations, they can build their own DROPS model so that if anything happens in the future, they can take into consideration their DROPS model and work on it. You can think about this as kind of a risk register, which also provides different types of mitigation and solutions to build the resilience in that way. But an other interesting thing was about that we found out was about the critical decisions that people have to take, and particularly for the production systems, how they can respond. Because in times of crisis, you need to know about the production volume which are needed. So, for example, in COVID-19, the demands were they were surged all of a sudden. All the bullwhip effect happened, where the supply chain struggled to meet the demand and so on. So obviously there was a mismatch between demand and supply. The time is important, how quickly you can respond to those. And in terms of the information is key, what is expected in terms of demand and what is existing capacity and expansion capacity needed. And that's where the repurposing also comes into play, because if you have to increase the capacity, you need to think about from where that capacity will come all of a sudden. So that is important aspect of dealing and tackling the disasters in that way. And obviously the required quantities are quite important to know in that instance. So all this, if we look into a typical production system, that equates to that we need some product types, we need to make some things, and there's some sort of product variance. There are some quantities required, the volumes required, and we are dealing with some customer orders in that way. And in terms of production control, we are trying to minimize or smooth down the work dynamics. In order to do that, we are basically dealing with a process and resource coupling. And based upon that sort of production system, we are responding to any sort of demands, either they are peak demands in case of a disaster and so on. And at the end, we are delivering those sort of products. You can think about this as at a conceptual level overall. But keeping in mind, with all the Industry 4 drive and so on, there are lots of technologies out there, and we have been looking at different technologies, and you can see this this network map, which is coming from the latest literature on Industry 4. And you can see there are lots of technologies, lots of different technologies. The Internet of Things, you can look at from the automation perspective, you can look at from cyber physical systems and 3D printing and blockchain and artificial intelligence and so on. So there are lots of them. I'm not going to go into too much detail on Industry 4 itself, but I will be picking up some of the technologies here in today's talk. So if we come back to the production system, so how can we make it smart? We can use different technologies at different instances, which can help in terms of dealing with an internal disruption which is caused by the external disruption or a disaster like COVID-19, for example. So this is another view in terms of which Industry 4 technologies you want to use and how you can use it. So that's another question here. But the main thing is that we want to deal with the disruption, and we want to build that sort of resilience so that we can provide the demand which is out there. So we can supply those we can produce those products or systems, and we can deliver those in time. So now let's look at the COVID-19 situation. So while we have been facing COVID-19, everyone is talking about crisis now. There are lots of talks about out there, many research groups who were not even talking about those crises dealing, who were not even thinking about doing some research or some other work. They have been working day and night on these sort of tackling with crisis, and how we can link the work that we have been doing with other domains. For example, linking the manufacturing with the hospitals, linking the manufacturing with other types of work, and so on. So we have seen lots of work going on, lots of talks and actual work on face masks, which is one of the crucial item needed in case of COVID-19. And people have repurposed or thought about new ways how they can make face masks. And people can make face masks at home, or they can repurpose different factories, and they can use those sort of face masks. So this is only one example. Then we thought about if you think about the manufacturing, 3D printing came out quite widely, and people use 3D printing for making PPE and also some ventilator parts as well, and there were many other parts. But the key thing here, we have been seeing several examples during response to COVID-19 of these 3D printing of PPE and ventilator parts and so on. But it's fascinating to see how different individuals and groups came together and collaborated on different aspects of making and delivering the most needed products and services in the face of COVID-19. So all that part in terms of the the drive in terms of the makerspace type of places where people can go and do some of the work and deliver to hospitals and other places. We have seen all that, and also to design products and provide those sort of design to manufacturing so that people can make those things was also quite key. One example is about the medical ventilators, the oxygen ventilators, which is quite crucial in terms of dealing with the COVID-19. At least it was very much more considered to be needed in the start of the pandemic as later, but it is still a very crucial part which is needed for the COVID-19 patients who go to the ICUs and so on. So there have been several initiatives that happened in UK. There was UK Ventilator Challenge, where tens of different large and small companies came together to design, develop, and manufacture new ventilators. And it was amazing to see how totally different type of production units were used to produce totally different types of products. For example, racing cars, jet engines, and vacuum cleaner manufacturers, they made ventilators by repurposing their production plants. However, the whole task was challenging. And there were examples, the other examples where people developed ventilators from scratch. So there was one example in Cambridge as well, where several of my colleagues and we worked together to develop a new ventilator, which was quite cheap and was made in Africa and so on for that population. So there were lots of ventilator-related examples. So the challenges in terms of the manufacturing was that while the pandemic has been ongoing, there have been certain rules, for example, the social distancing and so on. So how to work on continue making things while these sort of challenges are there? How can you do that, and how can you ramp it up by repurposing different factories? You can use the spare capacity, the people who cannot make different other things, which are where there is less demand during the pandemic. So that was the question. So one particular example I would like to share here is the work that we did on ventilators. It's published in Science Robotics and Journal of Manufacturing Systems as well. If you look at this ventilator assembly, if you think about that, you're making this, you're going to make this ventilator assembly, and how you can use different types of Industry 4 technologies here. So, so we picked up the collaborative robots in this case, and using the digital twins, two main technologies, which were coming from the high benefit, high complexity, for example, in terms of the robotics, and the simulation is on the upward rise from high benefit, low complexity, and might come towards high benefit, high complexity later on. We already talked about the big data and analytics and additive manufacturing in the previous examples, but in this medical ventilator example, I would like to talk about the collaborative robots and use of digital twins to make the medical ventilators more quickly with a repurposed sort of manufacturing environment. So in this case, you can think about the human-robot collaboration, the HRC cell as working. There are two humans working and two robots working, and you can place them in a way that that there is social safe distancing between the two humans, and you can ensure that if you're using these sort of cobots, you need less humans, so there is less sort of interaction needed in terms of making things. While the other advantages are obviously you can transport the cobots easily, they can fit into smaller spaces, and you can use them in the other types of production environment where the production is not as such carried out for the medical ventilators, for example. However, having said that, there will be some restrictions still they will apply, for example, in terms of the medical equipment manufacturing. So you need to maintain those sort of requirements, obviously. But in terms of the benefit in terms of reducing number of human operators required is quite huge. So they can stay at home or do some other essential duties. And by maintaining social distancing in factories in these sort of environments can also ensure safer colleagues, and the safe distances could be maintained between two humans. So this is kind of providing a resilience layer for future production in this case. So here you can see that different pick and place activities could happen, and the ventilator parts could be made using these pick and place activities, and these are the tasks that you can see. The 6 tasks in this case were based upon the robots, the cobots in this case, while the other remaining tasks up to 7 to 14 were for the humans involved in this case. So you can divide the tasks between the robot, the cobot, and the human so that they can work together. So another part of this was using the digital twins, so that you can see how you're working, and the physical thing, you can test that in advance, and you can go through design, engineer to the main operations afterwards, and you can verify those sort of activities that you are doing. So we use the digital twinning effect here as well, and you can see in this video how we came up to this this challenge. So the idea is there. Obviously, it needs to be employed further on, but the benefits are there. People have used cobots in other instances, for example, for conducting the swipe tests as well, for testing the COVID-19 results and so on. And there are many other applications that people could use the coboards in these sort of environments for building, for manufacturing the PPE and other aspects. But we can see that it can help in terms of repurposing the existing spaces, the existing capacity of a plant, and you can quickly deploy the coboards and you can set it up and to make the ventilators and so on. The other examples of the technologies could be around, for example, the augmented reality, which could also help in terms of verifying the processes and reducing the paperwork. And in a sense, it can help gear up the processes. But the main challenges would be in terms of having the right operators here, as well as the right applications which can help progress and ramp up the production. But it can help the other types of process because it can provide the flexibility in way of changing things quickly and repurposing things quickly, because you don't need those sort of the paperwork and other aspects related to this. So you can go through you can add the verification steps as well while making different types of programs which can help in terms of verifying what you're making, and it could be kind of a foolproof process when you're going step by step. The other technologies which can help is obviously virtual reality, but it could be mixed with digital twins and other types. So all these different technologies, they from Industry 4 drive could help in repurposing the factories as well. But obviously there are challenges in terms of the having the right workforce available, as well as the right applications and the development people available who can quickly do this type of work. So all this leads us to thinking about changeable systems. So where we can repurpose factories and we can ramp up production so that we can meet the surge in demands in case of any crisis. So how can we achieve that? I would like to provide another example here where we can think about how we can think about going towards changeable systems. So in this case, we looked at car production, particularly the door assembly. And you can think about from design and production perspective. So you have a product architecture on one side, where you can think about how that different parts are made and they come together, and what are the dependencies between different parts of that particular system. And then you can think about the processes on the other side, the manufacturing processes, the assembly processes. And you can think about the dependencies between the product elements and the process elements in this case. So this one just shows the original dependencies in case of the door assembly. So we looked at this, and we talked to three major automotive suppliers in this case, who were representing different different product segments from luxury, compact to premium, and they were quite big manufacturers. And they were also representing the product specification in terms of very broad variant to medium variant selections, so which can cover different types of product systems here. So when we look at the changeable systems, we need to think about how quickly we can change and how we can change and how we can reduce the dependencies between these sort of product and process linkages, and you can add the equipment and other like people aspect as well. So you can think about the multi-domain models here. But the main thing here is to look out for these red places, where in this case, this provides different scenario-based modeling of the product versus process, where we can see the dependencies from the visual sense in terms of the manual eye. But in this case, when we process it, we simulate it, what could happen, how things can go along from one side. For example, the change might happen from 1 to 2 to 3 to 4 different types of elements, or it might go to from 1 to 3 to 4 and to 2. So there could be multiple paths that can happen. So the main thing here is to watch out for those sort of red squares, which are representing the likelihood and impact of any sort of dependency happening and any sort of things going wrong in that case. So this is the risk here, is the risk of change. So which means if you change one thing, the other things will also be affected in this case. So in order to make a changeable thing, we need to take out these sort of red squares, or try to minimize them as much as possible in that case. So this is just an example which can lead us to think about that we can make a changeable system if they have characteristics of, for example, modularity. So these are modular systems, and modularity does not only come from the product elements, only the product architecture. It also comes from the reconfigurability of the production plant itself, as well as the changeability of the whole supply chain, and also the balancing between demand and capacity as well. The other thing is about simplicity. So how can we reduce the number of change relationships so that the architecture is simple, the product architecture, as well as the production layouts, the production machines, and so on. The third thing, because when you look at the layouts and the production machines, that's important if we are repurposing the factory particularly. So that can help in that way, how quickly you can do that. The third thing is about independence. So it means that the weaker coupling of existing change relationships, so that you can easily change things in that way. So this is a start of thinking that how changeable systems can be characterized and put into place of our working style in terms of the production, manufacturing systems, and so on, so that we can develop such systems, such factories, which can easily be repurposed, reconfigured, and which can help in ramping up the production levels required in that way. And the other thing we can think about is going back to the technologies, the Industry 4 technologies, how these technologies can help us achieve this sort of domain in terms of the changeable systems, and that is quite key. And that sort of drive is happening. Lots of things are on the way. Almost every country, at least in Europe, has their own Industry 4 version, and there are other places in the world who call it differently. There are terms like smart manufacturing, digital manufacturing, and intelligent manufacturing, and so on, are used for this. But the drive is happening rather quickly, and this sort of COVID-19 is also making the way in terms of taking some things more quicker in that way, particularly like the AI related aspects going into manufacturing and hospitals and so on are quite key. So what's the future? I think that links to the future in terms of thinking about how we can characterize the changeable and smart factories of the future, taking into consideration the Industry 4 technologies and the characteristics of the changeable, reconfigurable production plants, which can change when needed, which can be repurposed in case of any disasters happening. And we can apply these sort of Industry 4 and other changeable smart factories concept into different other domains. For example, Industry 4 could be applied into airports, where we can call them airports 4.0, for example. So you can use different types of coboards into the airport environments. Some are already being used at some airports, We have done, and there's some work still continued working with the Singaporean airport. We were looking at the application of the Industry 4 concepts into the airport as well. So there are lots of things in those sort of domains which are happening. But the key terms here are the repurposing changeability of the plants, the reconfigurability, the resilience to disruptions, which comes from how quickly we can go back to the original functionalities, and also the change capability into the future, and the Industry 4 smartness, intelligent factories of the future. So these are the key terms here. So in summary, the aim of this keynote was to explore how manufacturing has come up to the challenge of COVID-19 by repurposing factories. And we have covered, we have discussed some of these through looking at different questions and some examples that I've provided from the use of coboards for ventilator production and the automotive examples for changeability and so on. And we talked about some production in terms of 3D printing and face masks and so on. So on this note, I thank all people who have been involved, all the students, the collaborators, my colleagues at Cambridge and other places in the industry and so on. And thank you to all of them for taking part in some of these aspects that I've been talking about. So on this note, I thank you all as well for listening to this, and I'm happy to take any questions or any comments.
Thank you, Dr. Tariq. It was a very interesting talk. So we are open for questions. Put your hands up if you want to ask something. We have, Professor Mitchell.
Thank you. Very interesting, thought-provoking presentation. I have a question which I won't ask you, which is more about the social science dimension of disaster response. But in terms of the repurposing of factories, I've always sort of been thinking that the ultimate implementation of the digital world is a digital factory, which is therefore which is a programmable factory. It's just a matter of scaling scaling the things that you were talking about up. And do you think that the gains from doing this in terms of the productivity and in other words the efficiency of the factory will outweigh the costs of providing the infrastructure to make it reorganizable, because obviously having something that can be changed is more expensive than having something that's fixed. I just wondered if you had a comment on the economics of this process.
Thank you, Jeffrey. I think that's a very interesting question and has been part of discussions in the past. Lean versus resilience is a concept. So this sort of resilience or just in case is not new. In the past, people used to do just in case. Oh, I will buy just in case I need it, you know. So those sort of philosophies were there in the past as well. And then all the drive happened and we are used to more towards lean sort of approaches where we need something, what we need so that we can reduce the costs and so on. And most things have been happening in recent past as part of lean philosophies, particularly in the UK, there have been lots of lean applications have been applied. But it's a question that whether we can go away in terms of using the lean approach as well, because in case of disasters, you can't survive if you just stick to lean. You need resilience, right? And in order to be resilient, you need to provide some sort of redundancies, right? In terms of adding additional backups, right?
Yes.
So in order to provide additional backups, you need to spend more. So I think that sort of lean versus resilience is a question whether you can still try to achieve in certain parts, but not everything. That's my personal view, that you might not be able to achieve lean in everywhere because of the situation. For example, in case of medical ventilators or the additional capacity in terms of hospitals, in case if we need it, because we don't know the answer to how many people will come. Hopefully not anyone, but we don't know the demand. So that sort of uncertainty is driving our attitude towards going to resilience, particularly in that way. But on the other hand, if we embed the resilience into our daily lives in a way that is a balance between lean and resilience, I think that's the way forward, because in most operations world, or people say that most decisions are kind of trade-offs. So we need a trade-off here, which is sensible, and because on the other hand, we cannot make something like 100% backed up. For example, we're living in houses. We can't say that we need another house as a backup, So that sort of approach is, we cannot say that we can achieve 100%. So we need a balance somewhere where we think that, okay, this is resilient. These are the critical things, and we cannot compromise on these. And we need to go forward by having backups for these ventilators, face masks, all the other hospitals, and all the other life-saving sort of aspects. While on the other things, we might say that we need a different approach where we might look at different other ways in terms of lean. Does this answer your question, Jeffrey?
Yeah, in part. Well, it's just a different way of thinking about it. I would think that probably one of the parts of our society that will have the largest change post the pandemic will be hospitals, because the model of hospitals has been shown to be inappropriate for dealing with a broad-based disaster where you need a lot of medical input in different places. So
I think that's not a new thing in terms of putting the field hospitals. So field hospital concept is already there.
Yeah.
So people have been using that. And in the UK now, they have built like Nightingale hospitals. In China, in all different parts of the world, they have come up with these sort of field hospitals where you can quickly put up a hospital and start working on that basis.
Okay, thank you. There are some more questions that we have space for another one. Okay, if not, thank you, Dr. Tariq, and perhaps we could go to the next presentation. So thank you very much, Dr. Tariq.
Thank you very much for listening, and thank you, Jeffrey, for the interesting question. Thank you. Thank you, Arthur. Bye.
Bye.
Bye-bye.
So the next presentation came from CDRSP, and I asked Joana Valente to join us. Joana Valente is here, yes?
Yes, I'm here.
Okay,
Hello.
Joana, good morning. How are you?
Good morning, fine.
So, Joana is a postdoctoral research at our center, and she obtained the PhD in biochemistry in 2018 from University of Feira Interior. She started to work here in 2009, so 11 years ago, sorry. During this period, she worked with 3D printing and surface modification, increase the suitability of scaffolds for cell adhesion. She also is a postgraduate course integrated in managing systems from Polytechnic of Guarda. She's author of several scientific papers, and their main research interests are including tissue engineering, biofabrication, additive manufacturing, biomaterials. So she will give a talk in materials. I think I believe it's a mixing between metal and polymer, and it's inside the project, and the name of the project is Copoly, and these polymers reinforced with copper to promote antimicrobial effect. So I think that will be an interesting talk. Joanna, we'll start.
So I will try to share my presentation. So, are you able to see it? Okay, are you able to see it?
Yeah.
Yes.
Okay, so first of all, good morning, everyone. So today I will present the work developed during this project. This project was performed in partnership with LCR, Dreamplaza and the Polytechnic Institute of Leiria, and it is entitled Copoly, Polymers Reinforced with Copper to Promote Antimicrobial Effects. So, to contextualize a little bit, the current pandemic situation have led us to adapt to this new reality and to search for alternatives regarding the materials that we use daily. So it is often explained that the virus can remain on the surfaces and making them potentially vehicles for the spread. Concerning this, the development of materials with antimicrobial properties have arisen, and among the most studied are the ones combined with copper. So copper has been showing outstanding antimicrobial properties, and there are even studies showing its effectiveness in killing different pathogens, namely the coronavirus, in a few minutes. So how does copper kill microorganisms? First of all, copper dissolves from the copper surface and causes cell damage. Then there are the cell membrane ruptures, which leads to the loss of membrane integrity and also to the release of the cytoplasmatic content. After this, the copper ions induce the generation of reactive oxygen species, and they are these oxygen species that are responsible for the degradation of the genomic and the plasmid DNA that completely destroys the microorganisms. So the main goal of this project was use knowledge and protocols well studied and implemented by the academic society to create polymer copper plants able to be used to produce high-performance products with innovative characteristics such as the antimicrobial effects. So with this, will be possible to produce materials able to really protect users, since instead of being used only as a physical barrier against the several pathogens, these materials will have the ability to eliminate them when in contact. Concerning all of what I said before, the methodology applied during this project started with the mixture of different polymers with copper. I want to say that we studied several polymers. However, we only I will only show you the ones that we have better characterized, that were the the mixtures between Evopren 961 and Purell with copper. So after we did this mixture or these blends, we evaluate their antimicrobial and mechanical properties. And it is also important to say that until now, we the antimicrobial tests that we have performed were with the bacteria. So we studied two types of bacteria, the E. coli and the Staphylococcus aureus. So as I also said before, the next step was to produce cutting edge materials, to produce personal protective equipment or other products such as disposable medical products. Another important thing to be referred is that Copoli have a case study that consists on the production of a face mask with these developed antimicrobial blends. However, during this presentation, I will only focus on the development of the blends and on the characterization of the blends between the polymers and the copper. So, to produce the mixtures, we use this mix equipment, and then we inject these blends on this injection machine. And as you can see in the last picture, we were able to produce very homogeneous test pieces. So after that, the first characterization that we performed was to evaluate the antibacterial activity of the developed blends. In this case, it is also important to refer that we tested several percentage of copper with polymers. However, I will only show you the ones who present the more outstanding results. So we start by the disk diffusion method. We use this test mainly as a preliminary test, and also because it is really easy and quick to produce and to have results. So, and we also only, for this particular test, we only use E. coli. So as you can see by the results, 20% of copper, the samples with 20% of copper presented the most pronounced antibacterial effects, and also the antibacterial effect was only presented in contact with the sample, and which could indicate the non-presence of ions diffusion. So after this, we performed a suspension test in accordance with these referred standards. For this particular test, we evaluate the antibacterial activity for E. coli and also for Staphylococcus aureus. And as observed before, the samples with 20% of copper was the most effective for both polymers, regardless the bacteria study, and also the best bacterial reduction was performed for E. coli. After this antibacterial evaluation, we also performed contact angle measurements. And we performed this analysis basically because there are studies reporting that the hydrophobicity is usually related with increase of the antimicrobial effects. And in this case, and as you can see by the graphs, by this graph, the surfaces with copper are less hydrophobic than the blanks. And with these results, we can conclude, or they can indicate us that the antibacterial effect is more related with the Cooper effect than with the hydrophobic behavior of the surface. After that, we also performed a mechanical characterization, and we studied the maximum tension and also the Young modulus of our blends, and we compare our results with the control. So it can be observed, as in most of the cases, a slight loss of the properties in case of polymer Cooper blends. However, this loss was not significant to compromise the good functioning of the polymers. So at the moment, we are yet performing some studies, and among these studies, there are the antiviral evaluation of the blends produced. We also want to understand if these blends presented some cytotoxic behavior or not. And we are also assessing the minimum amount of time required to achieve antimicrobial effects. Concerning the case study that I previously referred, that was a face mask, we are at the moment doing some adjustments on the molds. As future work, we want to evaluate if these blends presented antifungal properties, and we also want to increase the amount of case studies where these blends could be applied. So, as main conclusions, we can say that with Copoli, was possible to develop several combinations of polymer with antibacterial effects. We can also say that until now, 20% of Cooper was the amount needed to achieve the highest antimicrobial effect for all the polymers studied. Also, Cooper appears to influence more the bacterial growth than the surface hydrophobicity. And finally, there were some loss on the mechanical properties of the Cooper polymer blends. However, this loss is not significant to compromise the good functioning of the polymer. We want to acknowledge the funding from Fundação para a Ciência e Tecnologia, and also from Centro 2020. And finally, I want to say thank you for you all for your attention. Thank you very much.
Thank you, Joana. Let's give a big applause to Joana. And now, if we have questions about this kind of compounds and production methods and other things, please, okay, make questions. Put your hands up.
So Arthur, I think Yuan Chen posed some questions by chat.
I didn't understand, sorry. I shared.
Yes, if you go and look in chat, there are a couple of questions which perhaps could be a starting point.
Oh, yes.
I cannot see it.
Okay, but I could spell the questions for you. Okay, so it came from Yuan Chen, and any polymer blends with Cooper did not show antimicrobial effect.
The polymers. So
yeah.
Okay, so as I said, we studied several concentrations, and obviously we began for the small concentrations, and then we go until the 20. The small concentrations did not present.
Sorry, Joanna. I think the focus on the question is this one. He tried several polymers, and it tell that may not work with rigid PLA as example. So I think this focus is if any polymer blends with copper did not show antimicrobial effect.
From until now, I tested both of these. I tested Evopren, that it's more like a rubber, and I tested the Purell, that it's made of polypropylene, that is more rigid, maybe more like PLA. And the interesting fact was that for both cases, 20% was the better concentration of copper to achieve the highest antibacterial activity. However, I should say something that maybe could help. So I am using powder without a totally controlled dimension. So we have at the moment some studies running where, for example, if we use nanoparticles, we can achieve even a higher antibacterial effect with a very small concentration of copper. So,
okay, you have another question. It says that 20% seems very high. What applications for this composite? Is there a threshold for medical use?
So at the moment, our main goal and what we are focused on was to apply for the production of this face mask. So one of the things that we also want to do, and we are in fact at the moment doing it, but I have any results yet because we are just in the beginning. It is to understand if these amounts promote cytotoxic effects or not in fibroblasts, for example. So I don't have yet an answer. We are just trying and to see what is the behavior of the polymers with this concentration.
Okay. I don't know why, but we are receiving several questions by message. So I have another one here.
Okay.
Comes from Imra. We know very well Imra.
Yes.
And he says, thanks, Joanna, for all of the presentation. As you explained that as you increase of copper content and the microbial effect increases, and it is highest for 20%. What is your opinion for not having highest effect in case of 25%?
Okay, it is a really interesting question. It is a trend, so it is not a thing that happens once and do not repeat. So I do not have yet an answer for that. However, I have something that maybe could be the reason for this happening, but I'm not sure, and I'm not sure if I will say something that is totally wrong. But I thought that one explanation could be, for example, when we are working with microorganisms, we usually do not clean the surfaces with 100% of ethanol or 100% of bleach. This is mainly because using this concentration, these compounds will not enter inside the microorganisms. And I'm not sure, but maybe this could happen with the copper too. Maybe it is too much ions, and maybe there are some competition or something between the ions, and they cannot enter inside the microorganisms and kill them. So, but I'm not sure. This is something that I saw, but I do not search yet about it.
Okay, thank you. I think that we don't have more questions, or let me see here.
Maybe one. Can I ask one, please? Can you hear me?
Yes, yes.
Just if you are predicting some changes when you, or some differences when you move to the antiviral testing.
I don't know yet. This is something we do not perform yet any study. The study that I already saw, the concentrations for killing the virus was less than the one that we are using now. Mm-hmm. So maybe
that will be a challenge for all of us that are trying to obtain antiviral protection, because not only the tests are more challenging, but it's a different scale. So we are working with the same challenges. We are already doing some antiviral, and a lot of questions rise when you change the scale, and you want the antibacterial protection for sure, because you have an infection here that is also provokes bacterial problems. But to go to the nanoscale, that will be a challenge. And if you have looked, there is not a lot of bibliography or references. Yes, it's going to be one of the questions that we are going to deal with, is that change to have also the antivirus protection. Or
but the good thing is also we want to we will be pioneers and
yes. We came. Yes, I've seen that you are a student, a former student of University of Beira Interior. I don't remember if I was your professor.
Who is talking with me, because I cannot see.
Yeah, I don't know what happened to my camera, but
Joana Curto?
Yes, yes.
Ah, okay.
Because former student, I think, or
okay. No, okay. I just did my PhD on University of Beira Interior, so I believe that.
Yes, because your face is familiar to me, but you are always welcome to come and check what we are doing, because we are working in similar, applying to similar materials and with the same goals. So I'm always welcome to
thank you.
Exchange experiences.
Okay, thank you.
Congratulations, Joana. Very nice work. Congratulations.
Okay, thank you very much.
Okay, thank you. Thank you, Joana. Thank you both, Joanas. And so we now move to the next presentation, and let me see here in my. Oh, sorry. It's Stelia. Okay, the presentation. The person that came to the presentation is Stelina Silva, and she is a researcher in EFE-MUP, Department of Physics and Astronomy at the Faculty of Science of University of Porto, here in Portugal. Prior to joining Porto, she was at the Polytechnic University of Valencia with a Marie Curie individual fellowship, working in direct collaboration with experimental groups on pressure-induced phase transitions. Her academic background includes a PhD degree from the University of Bath, UK, and master degree and a degree in physics, computation modeling and simulation, both from the Faculty of Science and Technology of the University of Coimbra. She came to talk with us about money laundering. I don't know what is a relation with physics, but perhaps we have a strong relation. So I'm curious about your talk.
Okay,
Please.
thank you very much. I'm gonna just share my screen. If I find, yeah. Thank you very much. Yes, like you said, so my presentation will be, it's not like all the other, it's slightly different because I'm just going to do a review, but its applications mostly, since I'm a physicist but a material scientist, it's mostly applications of materials to try and also fight this pandemic problem of the COVID. So yeah, so I call it a money laundering in my talk because it's also to give a overview of the virus transmission that also not only on surfaces, like the last talks also were saying, but also we have to think about the problem of the money transactions and the possibility of the virus transmission through these through this kind of items, right? Yeah, so just a short overview just for the motivation, but I'm not going to focus a lot because the last talks already spoke about it. But as we know, the problem of the virus transmission not only spreads with people that are infected, but it's also been evidence that the virus can be transmitted through exposed surfaces, much of the ATM machines, the check-in points in the airports, so surfaces that are touched by several people. Not only the viruses, but this COVID virus, but other diseases such as hepatitis is also known to be a possible transmission vehicle through these surfaces. So curiously enough, I just thought it was funny to show it here. This paper came in the media Nature that actually claims that the virus is really infected through surface through the surfaces, and so they say that no worries about that. That's not all the studies that have been done are wrong. So this guy came out with this theory, but curiously enough, in the end, he actually says that hand washing is crucial. So if it wasn't crucial, why do they say that surface exposure is not important as well? So it's a bit contradictory, this kind of media Nature paper. Yeah, so like I said, this overview that I'm going to show, it will be related mostly to the money laundering, since money is also a vehicle of transmission of some bacteria, viruses, even fungus. And so an idea to implement is try to apply well-known technologies, which is in this case using coatings or immersion of these items in nanoparticle liquids, and which these nanoparticles are known to have antibacterial and antifungus and antiviral properties. But in spite of all this, nowadays still people use a lot. It's the rules of implementation is cleaning the surfaces, doorknobs, tables, and everything. But however, if by implementing the idea of nanoparticles, coatings, which have these antipathogenic properties, the need of cleaning won't be that crucial because the nanoparticles will already have the properties intended for the cleansing process. Yeah, so like Joanna, the last talk was saying, copper nanoparticles is also a material that's being used for this kind of applications. There are also other metal oxide nanocrystals, such as TiOs, all oxide-based metals. And it has been shown through several studies that these may decrease the viral load to about 90%. Silver nanoparticles, I've found this actually recently. It's been one of the oldest nanomaterials used for antibacterial agents, and currently it's used for several applications in hospitals, for dressings, coating of medical devices, even lotions and gels for the hands. In spite of all these materials being well known for their properties, I would like to suggest, it's the graphene-based materials. These graphene systems are now currently being applied for several applications, and due to this pandemic situation we're living in, it's now good to also think that the possibilities of applying graphene, which is a two-dimensional system, but with amazing properties, not only the known antipathogenic activities, but also due to the superior resistant properties, which is superior to any other conventional materials that are known. Not only can it, when you apply for the money laundering or money cleansing process, or even this can also be applied to surfaces, of course, not only for the antiviral pathogenic activities, but it also can improve the mechanical strength of banknotes, for example, against tearings, due to the flexibility and mechanical rigidity of graphene system. Also, an advantage of graphene over other nanoparticles or metal oxides is that it imposes less environmental risk than the inorganic systems, and these are less toxic. They are biocompatible, and due to the low dimensional systems, it's also got a large specific surface area, which enhances the antibacterial effects. Yeah, so this is all the applications, like I said, of graphene systems, which has been thoroughly studied, and now due to the situation we live in, it's also good to now go and think of the possibilities of application of graphene for medical or biological applications. I'm just going to show some papers that came out also recently. Well, this isn't very recently, but it's a paper from 2016 that's already studying the antibacterial activity of graphene-based materials. So the study was based on E. coli, to the removal or degradation or inactivities of the E. coli bacteria. And it shows that, so this isn't pure graphene, so I'm speaking on graphene-based systems, which could also include, in this case, it's graphene, oxidized graphene, also known as the reduced graphene, in which it has, it shows that the E. coli can be inactivated with the application also of sunlight. So it would be like a photocatalysis process using a graphene-based systems. Also, some now more current papers that are coming out, reviews also are already heading in the direction of graphene applied for the COVID fight. And it has been seen that it's effective, since graphene also can not serve as only an antibacterial agent, but it also can be used as biosensors, which can help through the screening of the virus activities when exposed. Yeah, this is another paper also similar, which also shows the potential of the application of graphene-based systems for the applications of this combat, of this fight against the viruses. Like I said, this one is also very interesting, this paper, because it also focuses a bit about the biosensing properties of graphene to try and diagnose the viruses on exposed surfaces. Also, just a curiosity, graphene, actually, there is a company in Spain, I think in Oviedo, that actually are now applying graphene for mask faces because of the filtering efficiency of graphene as well. So you can see that the applications of the system is broad. Yeah, so I want to thank you. It was just, like I said, it's a review of applications of graphene for mostly for cleansing of surfaces and mostly for the money laundering process, which is a problem that people are also currently facing because of the problem of the virus. And that's why people also go now for the credit cards and everything in order to not touch the money. And this is possibilities to try and coat the money notes and coins in order to try and clean and provide a safety item, because this transmission not only it's between people, but it's also across borders. So because money is extensively transacted throughout the world, of course. Okay, thank you for your attention.
Thank you very much. Now, before lunch, we have some time for some questions. If you have questions. So we don't have. Okay. Professor Mitchell.
Yeah.
Professor Mitchell.
Do you think that from this that a better approach, because money passes through machines, that those machines could involve an automatic cleaning process? So, for example, a cash dispenser could have built into it a system for disinfecting the money, because to coat something is a surprisingly difficult process, as we heard in the talk from Jean Boulin, that there, in order to get some particles onto the surface, you've got to add a huge amount of copper to the material just to get a certain proportion on the surface. And maybe where there's an opportunity, and it's something perhaps cash machines should always have had in, in the sense that the processes where the money comes into some machinery, perhaps because we always have had the possibility of transferring a bacteria, and I know that there's been some reports in the past before the pandemic, which was commenting on the very poor quality of hand washing, so that there's some study made of the handrails in a shopping center. I can't remember where it was. It may well have been in the USA, and studying to see what bacteria were based there, and that there were many samples found which contained fecal bacteria, which is just indicating the poor level of hygiene of many people in cleaning their hands on a periodic basis. And so where machinery exists, perhaps it could be used, or it's, I think, common in shops when people have, certainly in the UK, when people have high denomination notes, that they use a UV lamp to test the authenticity of it. So that it could be an alternative way without having to introduce any particular coatings into the system.
Sure. No, you're right. Even with, well, acid coatings, but yeah, but if you also spray with aerosols, with nanoparticles, in fact, it could be effective as well. So yeah, you're right. It could be a system, an aerosol system or something like that inside the ATM, or in this case inside the ATM, which could actually spray the notes in order to try and cleanse them. So yeah, it's actually a good idea. So not only in the fabrication process, which mostly is where we were thinking when the notes are processed, a system to immerse the banknotes and the coins in these gels or these liquid nanoparticles. But yeah, with sprays, I think it could be also effective, of course. Yeah.
Thank you very much for your presentation. I don't know if again, and I don't know if there are more questions. I think we are in time. Have here. Okay. Here we have a question from Luis. I'm seeing in the here a message. What could be the economic impact is part of the future studies? I don't know if it came from Luis Fonseca. Okay, if the economic impact is a part of the future studies.
Oh yeah, well, like I said, what I presented here is a review of literature. Although the economic impact, of course, if you have to, like Professor Geoffrey said, if you have a system inside the ATM machine, of course, these have to be considered, or even in the fabrication process of the money. Of course, you have to consider or a spray system or something like that. That hasn't been studied because this is a review of the material itself. But of course, also what I have to say is that graphene is one of the cheapest materials that you can use, or if compared with, for example, silver nanoparticles or gold nanoparticles. So yeah, of course, the economic impact is important to consider. Like I said, this is a review of literature of the materials properties itself. But like everything, you have to consider the economic impact, of course, but it wasn't, this wasn't the focus of this presentation, so sorry. Sorry about that.
Okay, I think that there are no more questions. So I think for now and for morning, we could end and have a lunch break for 1 hour. So and then we will start at 2 p.m. So good lunch for you all. Have a good break, and we'll see in 2 p.m. Okay? Thank you very much.
Okay.
Explosive materials, hydrogels, liquid crystals, and conductive polymers for tissue engineering, drug delivery, organic electronics, and photovoltaics. He has extensive experience in development of new analytical techniques. The main objective of his work in this field is to develop a new hybrid instrument for which combines atomic force microscopy with optical teasers and studio in applications in both fundamental and applied research. So welcome, Filippo. We will talk, you make a talk for us about personalized, reusable face masks with smart nano-assisted destruction of pathogens COVID-19, a visionary road. This is will be a very interesting talk. It's something that is very important for us.
Okay, thank you very much. First of all, can you see my monitor? Can you see the presentation? Okay, so that's great. That means that we can start. Okay, first of all, I will, of course, like to thank all of the organizing committee and Professor Geoffrey Mitchell for giving me the possibility to present this research today. My name, as was shown before, is Filippo Pierini. I'm an associate professor of the Department of Biosystem and Soft Matter at the Institute of Fundamental Technological Research of the Polish Academy of Science. The title of this presentation is Personalized Reusable Face Mask with Smart Nanostructural Destruction of Pathogens for COVID-19, a Visionary Road. At the very beginning, I would like to give you some information about myself and about the place where I'm working. As you can see really well in this map, I settled down in Poland, but I'm an Italian origin scientist. This is quite clear since my surname does not finish with ski, as 90% of Poles. I'm living here in the Mazovian region in Warsaw, that is the capital city of Poland. I report here some images of the institute where I've been working. It's called Institute of Fundamental Technological Research of the Polish Academy of Science, so IPPT PAN. This is a quite new institute. I mean, the institute was founded more than 50 years ago in a kind of Russian structure. I mean that the Polish Academy of Science was structured at the time in this way, but now it moved toward other kind of institute structure like CNR, for example, or Max Planck Institute. From the point of view of the institute itself, is quite brand new, less than 20 years old buildings, very well equipped and with a lot of different research applied in this institute. Indeed, as you can see, the title and the name of the institute is quite meaningless from my point of view, because it's quite difficult to understand what is a fundamental technological research, but this actually fits really well what is doing inside, because the field of science that has been done in the institute is very diverse from this point of view. And this has been reflected even in our department, that is the Department of Biosystem and Soft Matter. Of course, everything here in our department spin around bio application, but of course there are groups working on optics, on synthesis of the materials, on simulation, people working with viruses, with bacteria, so is on rheology as well, simulation. So the multidisciplinary is not only at the level of the institute, but in the department as well. And here is my group at the moment. It's composed by me and plus other few people, around 10 researchers are working in the group, including postdocs, technicians, few PhD students, and some students that I didn't report it here. Now that I present myself, I start the real topic of the presentation, which is actually COVID and the protection from it. Here I report in the first slide two images that gives some information. Of course, I skip all of the basic information about the virus and so on, because I believe that the majority of people knows extremely well this matter. But what I would like to focus is on the stage, on how this pandemic affect us, and is clearly visible on the early stage. I mean, due to the restriction, the main restrictions change our life from different point of view. But from some sides, it's just strengthened some behavior, like taking care more about the hygiene, taking the distance, thinking really well what we are doing. But what really changed is the use of face mask. This is something that for the majority of us, at least for the European, is quite strange. I remember during the first pandemic peak, I was reading one very interesting article from a scientist, Asian origin, a scientist working in New York, that explained how it was difficult for her wearing face mask in the metro of New York, while all of the other people look at her as a kind of alien that landed in their city. While now the story is completely different. If you go in a shop, you see somebody without the face mask, and this is the alien. So this is explain really well how our life is changed. So face masks are every time with us. Nobody try to forget them. So it's something that really affects our life every day. Now we are entering in the second stage. Probably there will be few, but and it's hard to predict actually. But the second stage is characterized by the presence of vaccines. So people are starting to be vaccinated. Anyway, as you can see here on the last part of this slide, even at this moment, it's not possible to skip the use of face masks. So what is important to remind is that face masks are with us and stay with us for a lot of time again. So it's something that we need to have in our mind. And of course, wearing face mask is quite hard. So it's well known by everybody that wearing face masks for a lot of time is a pain in the neck. I reported 2 slides in which is clearly shown by all of us how uncomfortable it is, especially here for people wearing glasses. But we need to keep in mind that for us it's simply uncomfortable, but for other categories of worker is a very difficult matter using this face mask. I'm thinking maybe about the frontline healthcare personnel that are working in the hospital, in clinics, especially these that are connected directly with COVID patients that need to wear this face mask, especially the face masks that are with high filtration efficiency for a lot of time. You can see here how these nurses have skin damage by the wearing of face masks for really a lot of time. There are other problems connected with the use of face mask. One of this is the cross-infection. And of course, when we wear face mask and especially when we are sick and we don't know, because a lot of people does not have any symptoms, you wear the face mask and a lot of these viruses are accumulated in the face mask. At this point, the mask can be an additional source of infection. Here on the left, I report, I will say, a quite silly idea of having a mask station. Try to manage to have it in a school or in the canteen of your institute. You need to eat, you have your face mask, and then they offer you this kind of mask station. I believe that nobody would like to have this purple mask if the red one is of a people that is having COVID, but without showing any symptoms. Of course, this is a really extreme example for daily use, because I believe that the majority of people take care quite a lot about their face mask, but here is extremely important for people that are working in the hospital, especially people working in the COVID part of the hospital. And this was extremely problematic, especially at the beginning where there was a quite huge shortage of face mask. Another extremely important problem that now we are not feeling is the pollution. I mean, of course, now the issue is connected with the health of people. Of course, this is exactly how it should be. But of course, in the next few months, years, we will need to take care even about the pollution connected with the PPE, with the protective equipment that we are using for protecting ourselves from COVID. Generally, several million of tons of plastic every year are people get rid of them and reach the ocean. Here, this image explains quite well without any use of single words what is going on. Especially because now the number of plastics, it rise incredibly in the last year, exactly due to the use of masks, gloves, and other equipment. So it's something that we need to take care in the next few years. So it's a great challenge for everybody. So what is the goal for material scientists? Is generally to design a new generation of face mask that has completely new features. The features that we are willing to have is, first of all, self-sanitizing. This is due because, of course, with a self-sanitizing face mask, we don't have to get rid of them every day. So we decrease the amount of waste generated by the COVID protection. Of course, should be much more effective in terms of fit and comfort. We have seen at the very beginning of this presentation the effects of it on people that need to wear for a lot of time. Filtration efficiency should be still high. Of course, even now there are good filtration in face mask. You can have mask with different level of filtration. And everything is spin around, of course, multifunctionality and recyclability of this face mask. To reach this goal, we propose a path that includes the use of different kinds of nanostructured material. Here I report the main one that are electrospun nanofiber, plasmonic nanoparticles, inorganic nanocluster, and 3D printed structure. The use of them can be useful to generate material that have on-demand pathogen elimination. The killing of pathogen can be done by using stimuli responsive material. Actually, that's material that can be activated by light. Why light? Because it's a source of energy that is widely available, and this green is cheap, so it is one of the very best source of energy for triggering the elimination of pathogens. Of course, filtration should be very high. We need to have the possibility to control the moisture. This is extremely important part of this project because, as you have seen before in the slide in which I report some nurse wearing face mask, the use for such a lot of time creates some damage of the skin. And this is connected mainly with the humidity that is created under the face mask. I remember just before of the summer speaking with people, everybody were scared about wearing face mask during summer. And the main claim was, what will happen in full sun because it's super hot? How is possible to do it? But actually, temperature is not a great problem in wearing face mask. Indeed, if you wear for several hours, the temperature in the region between the mask and your face increases of just a couple of degrees, while the humidity is extremely rising over time behind the face mask. And this is what creates all of the problem of uncomfortability of this face mask and the problem connected with the skin damage. So we need to dissipate the moisture if we want to wear it for a lot of time in a comfortable situation. And the last feature that we need to have is a personalized face mask, because of course the face of everybody are quite different. So we need to have a face mask that fits perfectly with the contour of your face. And this is very important and useful to be done with digitally personalized technology. The first technology that I mentioned is electrospinning. Here I would like to give some basic information to everybody. This is a very interesting technique because it's the most powerful method to transform polymer masses into nanofiber, real nanofibers. It works like that. Here we have a syringe which is charged by a solution of polymer. It can be even a fused polymer mask that is extruded through a metallic needle. And the fibers are connected here in a metallic plate or a drum. Differently than normal extrusion, in which the fiber is created by the force of the gravity, essentially, here the force that stretch the polymer mass into fiber is electrostatic. Indeed, here we have a high power supplier connected to the needle, and the collector is grounded. So the polymer is ejected out through the needle, form this so-called Taylor cone, and enter in a zone, in a stability zone, in which we have a series of whipping motion that to the end form the nanofibers. Of course, not all of the polymer are spinnable. We need to have sufficient molecular weight, density, and several technical parameters of the electrospinning affect the final results, like the polymer concentration, the distance between needle and grounded collector, voltage apply, flow rates, needle diameter, and even the temperature and humidity in this area of electrospinning is extremely influencing the final results. Moreover, I would like to point out that this is a very interesting technique because it does not only form nanofibers, but is able even to stretch the polymer chain along the axis of the electrospan fiber. So we have a different conformation from different point of view. It's really hierarchical structure, and it's possible to see even here. Indeed, with this electrospinning setup, we can create core shell nanofiber, in which the core is made by one material and the shell of another one. All of core fibers, fiber in tubes, tubes in tubes. So really plenty of structure can be created, and even from higher hierarchical level, because we can have a spaghetti-like method, but we can deal with the collector just to have more aligned structure. Here I report one of our setup for creating core shell structure. The fiber look like this one in this typical non-oriented method. It's very important to point out that the fibers are really nanometric, not micro as the other techniques like extrusion, as I mentioned before. Indeed, the diameter of this fiber can be even up from dozens of nanometer to a few micrometer in terms of diameter. The application of this kind of nanofibers is really, really broad. Indeed, we can find application of electrospan fibers in sensor, batteries, fuel cells, solar cell, protective clothing and filters, scaffolds, energy storage, catalysis, really a lot of application. But this fiber give their best in the biomedical application. Indeed, it can be used for drug delivery, for creating scaffolds for cellular growth, skin repair, antibacterial, really a lot of different kind of application from biomedical point of view. The next kind of material that is involved in the preparation of this new generation of face masks that we propose are plasmonic nanomaterial. So that is a class of material that include all of the material having plasmonic nanoparticles. So plasmonic nanoparticles themselves and even their composite, that they can be used for biomedical application, electronics, optics, bacterial inactivation, disinfection, and many other applications. This kind of material are very cool because of their optical properties. The most famous plasmonic material are gold nanoparticles. These have very interesting properties, optical properties, because of their localized plasmonic resonance that is intrinsic in this material because of vibration of the surface electron in this material, that generate this typical absorption peak that is around 550 nanometer. But what is extremely important is to know that this the position of this peak, the absorption of this material, is strongly influenced not only by the composition, but even the size and the shape of nanoparticles. So at the very beginning, plasmonic particles were spherical, like here. But then the development moved toward nanorods. And in nanorods, the aspect ratio is vital for centering in the position that we design this peak, which is very important because this material has another very interesting optical feature. So that is the photothermal responsivity. Indeed, this material, when absorb light in this plasmonic peak, they are excited and they release the energy in form of heating. So practically, we can use this material to generate, to higher the temperature in a material, simply shining a specific wavelength light to them. Here I propose an example of some gold nanoparticles that we synthesize. We have rods. They have two different typical absorption. This is the most intense and interesting, that is the longitudinal absorption of gold nanorods. That of course can be shifted if we have particle with different aspect ratio. And when we shine light on this material, it generates heating. Here, maybe I need to go out to show you. Here we have a sol of this material. When we shine light, you can see in this thermo image, the temperature rise. You can see here the temperature that reach almost 50 degrees. Then when the lights that we radiate is off, like now, you can see the relaxation and the temperature goes down again. Here, okay. One of the very interesting advancement in this field is the synthesis of different shape of particles. As I told you at the beginning, the very first plasmonic particles were spherical, then moved toward rods. Now we have different shape, and we are very interested in gold bipyramids, so materials like this one, because the synthesis is quite easy, it was well developed, and the efficiency of the conversion of light into heat is very good, and we can explore much broader range of wavelengths and due to the sharp edge of this material, the intensity or the efficiency in converting light to it is very high. Another kind of material that is vital are copper nanocluster. Nanocluster are material containing from a few to few hundreds of atoms. These are material that are exactly in the middle between molecules and particles, and they are very interesting because they have molecule-like electrical and optical properties. They have, for example, photoluminescence emission in the visible range, and what is very interesting, for example, is the aggregated induced emission, the influence that solvent has in the optical property of this material. And indeed, this material found several applications in biomedical application, but not only. For example, they are strongly used in lead, for example. But one of the properties that we like a lot is the antibacterial properties. I don't want to spend a lot of time because today in the morning, Joanna spoke quite a lot about copper. But I would like to remind that copper, especially in form of nanocluster, because of the high surface of this material that is really super high, the efficiency in killing pathogen, including bacterial, fungi, and viruses, is very, very high. The last material that we want to speak about that is vital for the development of this new generation is 3D printing. Actually, printing is not a technique, but is a family of technique. Here I report the most famous, I mean, that the parents of few texts that are present now, like fuse deposition modeling, direct ink writing, ink printing, stereolithography, and two-photon polymerization. This kind of technology is extremely interesting now in the last 2 decades. Indeed, it became pivotal in the fourth industrial revolution, and it finds application really in many, many applications, I mean, from electronics to textile, furniture, and so on. And this is due essentially to the fact that it's possible to print with the actual technology very different kind of material, complicated and most importantly very small, from micro scale to large scale, like structure with bigger than 1 meter in terms of dimensional scale. One of the most difficult challenge in this field is the anisotropic morphology distribution during the process. That is very important even for developing new face masks, I mean, that to make more effective the process, because when you start printing with one kind of system, let's say, it's quite difficult to have a different structure, and especially from the point of view of supramolecular chemistry. For example, I report the possibility, typical impossibility to tune the crystallinity of the polymer printed structure in a typical process, but several groups are working in solving this problem. Here I really thank Professor Mitchell for giving me the possibility to show this slide in which is reported their own idea to how to solve this problem, and generated 3D printed structure with different crystallinity and molecular disposition. One of the most interesting techniques, part of the bigger family that I showed you before, is the direct digital manufacturing, because this technique is very powerful, because it's pretty much possible to print any sort of shaped material with different dimensions as well. And another concept that is very important for us, actually, for different kind of printed materials, is the concept of digital twins. Digital twins concept is something that is in common actually for all of the printing techniques, because it is actually digital representation of the physical object that we want to print here. For example, you can see an airplane. If you want to print an airplane, you need to have a model that simulates, that is mimicking this airplane. And this is a concept that is found application in a different field, from biomedical to really different application. For example, the definition of digital twin was given by NASA around 10 years ago. So now what we would like to do, we want to merge all of these kind of techniques to have a common goal to fabricate this smart face mask having different new features. First of all, I would like to remind that the target when we start thinking about what to do was, of course, the development of a face mask for frontline healthcare workers, because are the person that really need it at this point, is the main target. So the first thing that we have done is the use of plasmonic gold nanoparticles for functionalize the commercial face mask. So we synthesize these gold nanorods. These are particles that are sensitive to near infrared light. I would like to point out that this light is very interesting because it is fitting perfectly with the biological windows. That means that you can irradiate biological tissue. This light is not absorbed by the tissue and is totally safe. It does not create any damage. So if you shine this light through your arms, actually nothing bad happens to it. But when you shine this light on this kind of plasmonic nanoparticles, they absorb this light and they convert into heating. We have, for example, here two thermal image at time 0, no irradiation, and you can see the cold zone when we have deposited the particles. And after 20 seconds, we are able to reach more than 70 degrees. You can see here the profile and how fast is the responsivity of this material that, of course, this generation of heating remain on the top of the fiber because it is really localized at the nanoscale. And here you can see actually this is the region in which you can kill viruses and bacteria around 55 degrees. That is quite easy and fast to reach it because you can reach this 55, 60 degrees in like 2 seconds. So this the pathogen destruction is very fast. Of course, to do that, we are not studying only spherical particle, but even different shape. We studied spherical, cubes, rods, and we even bipyramids, because this allow us to use different kind of light, from sunlight to near infrared light with different sort of efficiency. Of course, we are studying even copper nanocluster. Here I report the synthesis that we are exploring, because this kind of particles, this cluster, can give new different feature in pathogen detection and destruction, as well as was shown today in the morning. Electrospinning. Electrospinning is at the very core of this idea. Here on the left, we can see, because we can use in different way. Here I report some functionalization, let's say, or of commercial mask. Here you can see how electrospan fiber appears when we use nanofillers, when we use this plasmonic nanomaterial as nanofillers. You can see in this TIM image that the fibers are completely filled by this material that make the fibers responsive to light. So you can, as you can see here on the right, deposit the fiber on the top of face mask. Here we have the needle, the grounded collectors, this is grounded here, and a face mask that is functionalized. And you can see a SEM image. This big cylinder here is the typical, one of the typical fibers present in this surgical face mask. And these tiny fibers are our electrospan nanomaterials having plasmonic nanofiller inside. So in this way, we can improve the efficiency of filtration and have some sort of functionality additional. Of course, we can even span a met before, as is done here in this yellow layer. And by an adhesive strip, we can make it as a sticker that you can attach it to the face mask. This is an idea. This is called Maya. Is a patent idea developed by Professor Zussman in Technion in Israel. Of course, electrospinning, it can be used even in a more complicated and effective way. And here we are starting thinking about the generation of a new membrane. The first thing that we would like to take in consideration is the possibility to dissipate the moisture behind the face mask on demand. So to do that, we are using electrospinning. We are using actually two different kinds of membranes. So it's a two-layer membrane. You should imagine that this red one here is the inner layer and the blue one is the outer layer. The red one, so the inner, should be hygroscopic. So what is doing this layer? This is a functional material that constantly absorbs humidity that is created between the mask and your mouth. Then you have on the top electrospun photoresponsive material, exactly as we have done before with these plasmonic nanoparticles. When the moisture is saturating this first membrane, you can shine light here, the temperature rise, and you can dissipate the humidity on demand. This kind of structure can be even more developed. Here you can, of course, add gold nanoparticles, and as well we can fill it with nanocluster. This is the membrane, inner layer, outer layer, with the nanofillers inside. When you shine light, as we showed before, we can dissipate the moisture on demand, but we can reach even the right temperature for killing the pathogens on demand. Of course, in all of this story, personalization of the face mask is extremely important. So I will say that the use of digital twins is very important. Here I report on the right, digital twins taken, developed by a simple image taken from a mobile phone. You can reconstruct a meshed image of the contour of the face of a person, and you can print the supporting stuff directly on the membrane, using and having the possibility to have different kind of materials and geometry thanks to the powerful possibility given by the 3D printing. Of course, in this way, we can have a brand new type of face mask that have completely different features, because normal microfibers-based fiber have good filtration, but nothing more. If you are using smart hierarchical structure nanomaterial, you can have an on-demand pathogen elimination. It can be activated by light, as I show you, with different wavelength. The filtration can be even higher, and of course we can dissipate the moisture that is extremely important and can be personalized in base of the contour of the face of the people that will wear this face mask. But of course, not everything is simple as I show you now, even if different techniques are required. As was pointed out today, one of the biggest challenges is on the bio side because of viruses. Now, a lot of people are publishing, even in good journal, claiming the use of new kind of textile with anti-pathogen features. but the majority of them are tested on bacteria. And so one of the main challenge at this point for all of us that we are mainly material scientists to move toward viruses. And this is really something very challenging because working with viruses is very difficult, almost impossible. There are some models made on macrophage, but is one of the bottleneck in this field for everybody. So concluding, I would like to thank all of the people that were involved in this project. Professor Geoffrey Mitchell from Polytechnic of Lieja, Professor Karin Kojanar from Tartu University in Estonia, Dr. Monica Foxen from Babes Bolai University, Professor Luciano De Sio from La Sapienza University in Rome, Dr. Francesca Petronella from CNR in Italy, Professor Eyal Zusman from Techion, Israel Institute of Technology, and Professor Binding from Donghua University in China. Of course, I'm open to any question, but I really suggest even to read this paper that describe even in much more detail the story that I have just told you now. This was published 1 month ago, so you can find it online on Chemistry European Journal. Thank you very much.
Okay, thank you, Filippo. The presentation was very, very, very interesting. So we have time for some questions. Filippo. We have some questions. So I have one. I don't know. I have one question. So the idea of rising the temperature by using the light is when it's controlling the light, and so with the mask out of the face in a special moment, or with the mask in the face by using the daylight.
No, actually, the idea is having the possibility to do both, because, you know, if you are a person that is working in a COVID hospital, for example, you need to sterilize at this specific moment without removing the face mask. And, you know, in this case, the very good things is that the generation of the heating of the heat is very localized at the nanoscale, thanks to the property of these plasmonic nanoparticles that are on this membrane. So the temperature rise is mostly concentrated on the surface of on the very top of the face mask. So the idea is of giving a material that can be sterilized on demand even when it's on, even because we plan to use wavelengths that are completely safe.
Okay. Anyone have another question?
Hello?
Yes.
Here's Michael Hirzik. I have just one question. Can you just show us a slide where you have the mask with these plasmonic particles, especially gold particles?
This one, you mean?
Yeah, that's correct. That's fine. This is exactly what I want to ask about. We have in this slide a situation where you increase the temperature going up to 75 degrees.
Yeah.
This image is done on the mask, which involves the gold particles, or how to understand it?
Yes. I mean that this is the face mask. This is a commercial face mask. We synthesize our gold plasmonic particles and we simply drop the solution. The sol actually is a colloidal system on the top of the face mask. You can see here when the light is off, and then we irradiate with near infrared light. Here you can see this.
You use laser light?
Yes, yes, of course, laser. I mean that this is, yes, yes, of course. In this case was 808, so typical green laser for.
Yeah, but look, the temperature increased up to 75 degrees.
Yes.
The question is, how intensive was the beam of the light? Because if you use the just sunshine, you will not have 75 degrees. The question is, if the temperature should increase, then it will be dangerous for the people.
Sure.
75 degrees. How to understand this? What is the intensity of the light?
Okay, here the intensity of the laser beam was quite high. So in this, it was simply to show the potential of this system. But of course, as I mentioned before, everything now is spin around the synthesis of more efficient particles that can be activated with even mild irradiation. And of course, it's possible to use different light, as we said before, solar light, or infrared, for example, or even white light. But the design of this functionalization should be really made in base of the final application that you want to reach. Because if you want a face mask that is responsive to solar light, of course, you cannot having a system that reaches 75 degrees, of course, because it's impossible to wear it. Of course, the heating is concentrated, let's say, is localized on the top of face mask. So, but anyway, it's very hard to think about the utility of this system. On the other hand, if you want a face mask that want to be disinfected on demand using a specific wavelength that is not, let's say, available in nature, it's better to have something more efficient. So let's say everything spin around the final application of the face mask that you want to obtain. But of course, in this case, you can simply dilute the system, dilute the colloidal system, and you can have less responsive material, let's say.
Yeah, you want to kill, in general, you want to kill viruses, small particles. And yeah, the distribution from this image where you have the, show us the temperature, we have mostly in the center, the 75 degrees is concentrated. That means maybe all these particles are in one spot. They are not.
No, this is because the laser was focused here. It was 2 centimeters, less than 2 centimeters in terms of diameter, the spot. Of course, if you expand the beam all over the area in which the particles are present, all of them will be irradiated, and in all of this area you will have the rise of temperature, of course.
Okay, thank you.
You are welcome.
Thank you very much, Filippo. I imagine we are on the time for the other presentation. Congratulations about the excellent work, Filippo, and we now go for the next presentation. Thank you again. So now we have a presentation given by Joana Curto, and Dr. Joana Curto has her expertise in development and optimization of cellulose fibrous materials and biopolymers. She's professor of chemistry department in the Beira Interior University here in Portugal. She has more than 20 years of experience, research and development of projects in the field of sustainable process and products. Her method to design polymeric porous material is based on experimental and computational optimization approach. She has been publishing, coordinating research projects and supervised theses as a member of Fibromaterial and Environmental Technologies Research Unit in collaboration with other international research centers. So Joanna will give a talk about one of the fields of his work, her work, computational modeling and simulation to develop multi-structured polymer-based fibrous materials for antivirus individual protection. So is in the more or less same idea of the last one. So Joanna, please.
Thank you, Arthur. Thank you for your kind presentation and for the invitation. I will be sharing the screen if you allow me. I don't have the camera. I don't know why, but I did have it in the beginning of the session.
No problem.
Okay, just asking to. Okay. So can you hear me fine?
Yes, yes, very well.
And you already think the screen.
Can you? Okay, thank you. Thank you. So I will be presenting a 3D computational modeling and simulation as a tool to develop multi-structure polymer-based fiber materials, in this case, with applications for antivirus protections. Okay. The kind of protections we all are developing, and as we have seen, a lot of work has been done because of the pandemic situation, but it's going to be an improvement for all the safety, not only our individual but our military forces and doctors. So this is going to continue, and we started this work with the concerns on safety, of course, but also sustainability, and having an approach which is quite unique by using enzymes, which are a way of obtaining properties using biosystems, and also to not only have safety and sustainability, but also an approach where we are using active molecules from essential oils made from plants, where we add a function to our mask. So I will talk about a little bit of the work we have already done and published, but this is a work in progress, so we are going to continue. And especially, I will relate how the computational simulation is used to improve and develop these materials. Okay, this is just the materials. So we are using cellulose from bacteria, which is a nanocellulose. We are also using functionalized cellulose, carboxyl methyl cellulose, that we modify to obtain hydrophilic or more hydrophilic properties, and other biopolymers like alginate that come from algae. So our idea is to use these biopolymers to build our materials. One of the main material that we use comes from eucalyptus, because we are a country where eucalyptus is a source of cellulose, and what we are already able to do is to work with microfibers, which is common, the fibers that we use to make paper, but also with nanofibers that we deconstruct, we separate, maintaining the fiber structure from the microfiber that the eucalyptus made, and we are able to obtain these nanofibers. And as you can see, they are different from the fibers obtained by bacteria. They form a gel structure that you can see here in the screen. And nowadays we are able to make them from more sustainable ways. Here, the example I've put here, I was using Tempo, which is a mediator, and now I'm able already to do it using only enzymes and mechanical homogenizer, which means no chemistry that will concern us or no chemistry, more strong chemistry is used to obtain this nanofibrillated cellulose. This is a material that was not here some years ago, but now is very useful to you because of the scale, because we can change the properties relation with the water. It's very useful to develop materials like the materials we want to do here, protection materials, but coming from polymers that are biodegradable, that are biocompatible, and have this kind of properties. This is to show you what we are really making in the lab and in the industry, because this is scalable and we already have put it in a pilot scalable level. So what we are really doing is we are building a material that has several layers. As you can see here, I'm using fibers that have micro scale. The nano scale I cannot show you in this image at the same time, but they are there to fill the voids and to obtain the porosity and the softness that I want. And it's all about making these layers. So here we see a mask, one of the layers, in the Z direction. And as you can see, we'll have like 10 to 12 layers. And what happens is these layers are random. So the fibers are deposited randomly, and a virus or a bacteria is not able to go this path. And the tortuosity is a key factor to obtain what we want. We don't want our virus or bacteria to progress. And this tortuosity and the size of the path is what makes it impossible for the virus and bacteria to progress, or saying in another way, to be retained in the layer that we want. Okay, just some methods that I've been using to obtain fibers and pores characterizations. As we have seen, not only the fibers and the dimensions, but also the pores are essential to make the material, especially because we want that tortuosity, and also we want permeability. We want to be able to breathe in our masks and to control humidity. So the techniques that we are using are related to that. Water interaction is one of the key properties for one of the layers. It has been already we have already heard some presentations speaking about that important relationship. We want to retain water. We want to have more comfortable masks. And one of the methods that we have developed at University of Beira Interior is a 3D method, where we are able to see the deposition of a drop and spreading it in our structure, in our fiber material structure, and not only measure the kinetics, but also the retention of this water. And so we can really check with this characterization method the changes that we made in our materials, how are they relating to the final end-use properties, to the final properties that the consumer uses. One of the innovations here is the use of enzymes, as I told you, because we are the layer that is in contact of the skin, the mask layer, it's causing a lot of problems. For instance, for me, it causes allergy problems, acne problems, and if we can change the softness of our materials, and it's very different, as you know, if you think of a tissue paper, it can be very soft. Or if you think of a toilet paper, both are made from cellulose, or board paper, they are both made from cellulose, but they are completely different in terms of softness. One of the ways that we can change the softness is by the use of cellulose and the enzymes that go in the polymer material, and really change this property. And these make a difference when you need to use it for a long period of time. Well, we are already proved this improvement in these materials, measuring the softness. Other approach that is innovative is the use of molecules that come from essential oils. Why? One of these, because they they are active molecules. So not only want to make a mask that is safe, sustainable, but also that is tailor-made for this, for the person that is going to use it, or for the function that we want. Here are some examples of the use of enzymes to treat our fibers, and the results obtained indicate that we can improve in more than 50% the softness of this material, which is quite interesting for the development. Here is an example of the incorporation of molecules from an essential oil. In this case is tea tree oil. In Portuguese it's called melaleuca, but it's tea tree essential oil. And the active molecule, the molecule that has therapeutical properties, is this one, the terpene for oil therapeutic molecule. And it's known in the literature that is it has properties, skin properties. It's smooth, it is regenerative. It also has a very good biocompatibility. So if you use a mask where you have this tea tree oil molecule, you'll have, not only you avoid the problems of allergies and inflammation, but you are using a molecule that has a therapeutical effect. Okay, so this molecule is already used for skin care, and we were able to put it in a mask and to test it, and we are able to retain it there and release it. That's what we want to do if we want this layer to be effective. Okay, to obtain this controlled retain and release, the approach is to use a 3D computational simulator where we are able to optimize the pores. So instead of doing an experiment by trial and error with this computational simulation, we are able to do 1,000 experiments, changing the parameters that we can change in the lab and in the industry, and then to search for the optimums, and then to go to the lab and verify if these optimums and work around this. This allows us to save a lot of time. It's the same principle that you use when discovering molecules or docking proteins, is the same, but applied to materials. Here we have control to the size of the fibers, the interaction, the flexibility, so the change in polymers that occur, and we can program these in the simulator that we have developed. We can program and obtain different computational design of experiments and benefit from the optimizations done in the computer to go faster to our materials optimization. Here is just an example of the validation. Of course, if we do something, a material in the computer, we need to have developed techniques to validate it. This means the structure is the same, the porosity, the tortuosity. So one of the steps that give us a lot of work, but is indispensable, is to do the validation. So in this case, this has already been done for this kind of materials. So we are able to say that the material that we make in the computer is the same, with the same porosity, bulk, tortuosity, thickness, relative bonded area, that the material that we are producing in the lab in a small scale and after in a pilot scale. Okay, this is the kinetics control release. Here, not only we have a molecule that comes from an essential oil, but also a traditional drug, non-steroid anti-inflammatory drug, that is diclofenac, which some of us use when we have pain or inflammation in one of our parts, to say that we can combine both the principles. If we want to put another molecule that is already proven to be very effective, is not a problem, and we can do it for different pHs, which is important when we are dealing with human interaction. This is some results about the spectrum characterization, just to show you that we are able to see what is bonding and not bonding. and also some calorimetry results that indicates that we are able to retain the essential oil from the tea tree. We want to retain it because we are going to use it in a mask, and our temperature is 37 degrees. So if we are able to retain it for our temperature, that is ideal, because what happens with these essential oils is that if you don't use a 3D matrix of cellulose, what happens is that before 38 degrees, all of the oils have been evaporated. So you scent it, it's a very nice odor, but you don't retain it time enough to have any impact in your mask and in your skin. So the way to do it is to incorporate the molecules, the active molecules, in a 3D matrix. As you can see here, you were able to retain, and at 50 degrees, almost of our molecule was retained there. So this is very effective because our skin is at 37 degrees, as we know. What kind of molecules are we testing, and that will give you our mask something that they don't have now? One of the molecules is from eucalyptus, is eucalyptol, and as you can see, is a pathogenic for bacteria, is also very good for respiratory disorders. So if you will put it in a mask, you will have this therapeutical effect. This, we have already done it in the lab. So this is combining the fibers that come from eucalyptus with the molecules that the plant makes to protect himself from diseases, and these molecules, this is a study from to prove that this is effective. The innovation here is to be able to retain and to use it in a mask. Okay, not only when we are using essential oils from eucalyptus or other plants, not only there is a main component, but there are secondary ones that I usually characterize by GC, chromatography. And these components, what we realize is that they all have a function. Not only the sense of eucalyptus or menthol that you can sense, menthol will open your respiratories and will help you breathe, but the other components have a function. The tree makes them to improve volatility, to have a lot of functions. So one of the aspects that we are working is the chemistry and the association of the major components of these oils, but also the minor components that in changing their properties, for instance, from different species, we have different percentages. And if we change that, we are able to change a lot in the chemistry of these molecules. One of the aspects that I find very interesting, one of my students did present a thesis in this, is the use of grapefruit oil. Why? Because it's not related with respiratory problems or skin problems like tea tree or eucalyptus, but it's related with something that concerns a lot of people, which is losing weight. That means if you put some grapefruit oil in your mask, you'll have an effect that reduces your urges for food and controls your appetite. I didn't believe it if I didn't read it in a paper. I thought this could not be, it's so good. It's too good to be true that you have an odor, a sense, but the fact is that citric sense, grapefruit is a citric sense like lemon, orange, and grapefruit. This was proven with mouses. Now, this is the kind of molecules and additional functions that we can add to our masks, to our protective equipment, and have a mask that have a second function. Okay, this is the grapefruit, and as you can find the paper. Okay, to optimize this kind of retentions, this is some of the work I've done where there is a combination of the simulation tool and different scales, different techniques, electrospinning, casting, to obtain hydrophobic, hydrophilic for the different layers. This is an image where other biopolymers are used. I'm just searching for the time. One of the things that is more important when you are building a model or making a simulation of a material that is made by fibers is to have a good model for the fiber. Here is some of recent work where we have model nano and microfibers, cellulose microfibers, and here is the structure that we make in the computer. As you can see in the left, our cellulose fibers can have a void inside, can have a thickness of the wall, and we can make our structure, our layer of the mask, mixing this combination of these fibers. One of the properties that related with the strength is the relative bonded area. So here we have seen that we have analyzed porosity, relative bonded area, and thickness. So all of them are important for the final end-use properties, for the properties that the consumer wants. Here are some references where you can find more about the use of the computational simulation to optimize this kind of material. I'm not going to go very deep, but I've chosen these images because here you can see that I'm mixing two kinds of fibers, and then I'm building my material in the computer, and what I'm changing in the right is the thickness of this material. As you have seen the same image in the lab, I can optimize the thickness that I want to retain a virus, a bacteria, or to retain a functional molecule if I want it. So this will be used in the several layers of our masks. Okay, one of the things that these materials will, we are also working on this, is to print or to emboss or to have a 3D effect. As you can see here, these are images of cellulose-based materials, and here we have a hole. That means that if we print a pattern, we also are able to retain more water. This is very important if you want to control that effect, that is the humidification of your protection mask, and you want to retain it in a layer, and you don't want it to be in contact with the skin. So this layer needs to have can be optimized using the right polymers, but also using mechanical 3D effects that also can be modeled using the simulation. Just to end, this is a work and the approach of the unity that I belong, fiber materials, and we work with a lot of materials, and we also are concerned with the sustainability of our processes and our effluent. So this is a work, this is the philosophy behind our projects. One of the projects that we are working to join this is to obtain cellulose fibers that come from materials that already been used. One example is a paper, a technical paper that usually is only one use material, but what we have made is that we have made a process to recycle it and to separate the cellulose fibers from the siloxanes that are the hydrophobic part of this material. And after this, we can use them both to build the materials that we want. I will just go quickly here. I don't know if I've put here some image that you can see. And one of the important things of our research unity is that we are able to go from laboratory scale to intermediate pilot scale and then to industrial pilot scale, which is we have in our facilities. So here you see that our technical material was like this, and we are going to transform it in a material that can be used in a mask. I'm just going to go ahead. This is already in pilot scale. This is a scale that goes very well before the industrial scale. Okay, so we have tested to incorporate these molecules, the use of enzymes for protective materials, and protective materials are not only masks. We know that we need a lot of other things for the doctors and for the people that are in contact with the virus and for military protections. So here are some of our facilities. In the right I will show, this is our pilot paper machine. That means that we are able not only to develop this material, the 3 layers of the mask in the lab, but also to make it in a pilot paper machine, which has a box for the mixture of fibers and also a drying sector, where in the final of this machine, you will have a material that is a film, and you can really build it here. So this pilot paper machine is quite an important facility to go from the lab scale to the industrial scale. Okay, like a lot of people today in the presentations, we also work with electrospinning, and we incorporate molecules. And the things, the challenges here, I was completely in agree with all the presentations before. We have here an important technique to go down in the scale. Also, we can combine this with the 3D simulation. The challenges in my in my vision is that we want to functionalize with non-toxic molecules, have a greener approach that you already compared to others. We want to use nano micro scale to control porosity and permeability, and we are using 3D simulation to optimize surface properties, bulk properties, and layering. Okay, this is we have a certified ISO standard lab. That means all our testings are made with the standard ISO standards. And in the end, our material needs to be approved it needs to be certified. The innovative approach that I think it's here is that we are using 3D computational simulation. We are using engineering, advanced engineering to modify the fibers, the enzymes, the molecules that are functionalized, all of this to obtain optimization, and then to make a tailor-made mask where we can incorporate functions that we didn't think before, but that will give us these tailor-made protective materials with other properties and other functions. Finally, to thank you for your attention. The questions that are still there, and I think will be as a societal challenge for all of us in the world, are sustainability, eco-friendly processes, full cycle materials assessment. Sometimes you really need to do that to prove that your proposal is better, because you need to have in consideration the energy bill and some of the separation process or recycling. If they spend a lot of energy to do it, they are not greener than the previous one. And these are for present and future solutions. We only have one planet, and I thank you for your attention.
Thank you very much, Joanna, for your very interesting presentation. So we have, okay, we are a little bit of delay, but we have time for 1 or 2 questions. So there are someone that have a question about subject. So I have one question. About the process, we nowadays we are very dependent on melt blow and spin bond. I think that are the terms or the process to produce the filters for chirurgical masks and other masks. We know that almost all these things came from perhaps from Asia, but we are very dependent on these processes.
Mm-hmm.
The approach that you are suggesting to make the filters or the masks are based on similar or really very different processes? This is the first question. And the second is, have you already been contacted by some companies to work on this, to put it in industrial scale?
Comparing with, you were talking about spun bonded, where the bonding is made on non-woven materials by heat, right? To compare with these materials, spun bonded, non-woven materials that are traditionally in the middle section of a mask, right?
Melt blow, I think, is the middle. Spin bond is for the TNT.
Okay.
Okay, it's more or less.
The technology, well, the technology, this is a non-woven material like electrospinning will be, and the kind of bonding that you obtain will depend on the groups that are in the ending of your materials. When you work with cellulose-based materials, I was going to search here for a structure, the bonding will be from OH bonding, which means covalent bonding, and usually the process will happening in a water-based, it's water-based, it's like a filtration, and when you remove the water, the bonds are made from the fibers, they are OH bonds, so your material, these are the strongest bonds, so our material is bonded because you remove the water and there is an OH bond that is established between the different fibers and different layers. I was searching here for a picture, maybe this one, okay, this one, okay. So can you see it?
Yeah.
Okay. So this is one of the layers. The way you make the layer, one of the layers can be made by a water-based process, like paper is made, and you can also make the layer like electrospinning, a second layer in the top of this one. The thing is that you want bonding. The bonding in this layer will be, if you remove the water and you use heat, this is a bond like it's in paper, in a tissue paper, a napkin paper. So this is a bond that is very effective. And also, if you use electrospinning materials for a second layer, I will show you here one of my materials. Okay, here, can you see? Okay, here we have one of the layers is a microfibrillated cellulose, and the second layer was done by electrospinning or by casting. Okay, so in these cases, if you using the electrospinning, you can use, as you know, other polymers and other materials. It depends in the price, in the sustainability that you want to obtain. But here the idea is to use biocompatible and biodegradable polymers. So if you will have a mask and a protective material that is not going to add to the plastic problem that we have, but is a material that will be sterilizable or use again, or will go to the ground and to compost and will give you sugars or energy. All of them will give you energy. All the polymers will give you energy if you don't know how to do with them. But this full cycle assessment is the strategy behind the choosing of these polymers. But about the bonding, I didn't know if I did answer. Sorry.
No, I only was asking because we are very dependent on melt blow and spin bond, spoon bond, and I'm asking if this could be okay. This is a very different method, and also if there are already some I don't know, companies that are interested on this approach for this application.
Yeah, thank you. I did forget about that. The philosophy of our research unit, we are in a textile based city, and the engineering here and in Coimbra, and all of the, I also work as a researcher in the University of Coimbra. The philosophy behind our projects is always to work with industry, sometimes to solve problems, sometimes to go ahead. So in our cases, we have, I didn't put it here in this presentation, but we have several of these projects are with collaboration and in bigger projects that are industry proposed. One of these projects will be Impactus, which is from Navigator company, and also from the other paper companies. Not only this, but all the from forest to plants to to sources. So our philosophy is to work to work in projects where this is going to be applicable. Also, this work is textile, paper materials, raw materials. I think I've put here some of the, okay, some of the, but the companies, yes, we work with them from the beginning. It's like it's a continuous interaction.
Okay.
So,
thank you.
Did I answer?
We are running
yes,
out of the
of
time.
course.
So thank you very much for your very interesting presentation and approach. We have now, perhaps I suggest, as is in the program, a coffee break. So 5 minutes for a coffee break, and then we come at 35 past 3. Okay, it's okay for you?
Yes, of course.
Okay, thank you very much, and see you in a couple of minutes with Professor Mitchell on board.
Okay. Right. So we've reached 3:35. So time to restart the session. Thank you all for joining us for the last presentation, which will come from Professor Neil Rowan, who is at the Athlone Institute of Technology in Ireland. And I just remind those of us in the Polytechnic of Leiria that the Athlone Institute of Technology is one of the partner institutes in the European University Network, which was launched this year. And so it's a great pleasure to welcome him as presenter, but as a colleague. I'm guessing we're all in the same same institute. He is going to present a lecture which is particularly well suited to being the closing lecture to this, which is pivoting beyond COVID-19 pandemic by supporting and enabling communities and enterprises to transition to a low carbon, need to scroll, a low carbon economy, and empower ECO case study from the Republic of Ireland. So very much welcome to you, and we look forward to your lecture.
Thank you, Jeffrey. It is absolutely a pleasure to take your invitation today, and I totally agree with you. We are actually in a large family now with the Run EU network. I'm just going to share my slides now. I think the title is very relevant. I suppose in the context, I've been 30 years plus in academia. I was at Strathclyde University in Ireland, then thereafter I think it's 26 PhDs. But like a lot of people over the years, basically, I'm just looking at the from current slide, sorry. Yeah, so basically, Jeffrey, as well, I suppose in the context of this and what I'm trying to convey today is that I've had X number of PhDs. I've got 8 PhDs now at the moment, 2 postdocs, and it's cyclic. And in terms of, I've been so many years developing sustainable and disruptive technologies that I've been moving on, and it's very hard to retain people and for knowledge transfer. So the idea here is that Ireland and across Europe, we're looking into a transition to what would be a low carbon economy, particularly, and I've set this in the context of the Irish Midlands environment, because we're particularly focused on and have been on burning peat in the peatlands with the view of a mainstay for the country, and it's one of the second highest unemployment rates in Ireland. So in the context here, there's 3 things I'd like to deliver by way of the vision of the presentation today. Is how actually we look at a sustainable approach to looking at communities, and let it be from industry 4.0 right through to digital market, right through to agri-food, across from a bottom-up perspective to trying to get people to change in terms of behavioural change, but also from a top-down perspective with policy and in terms of facilitating this. I'd also like to connect this in terms of plastic, bioplastics with the view of COVID, in terms of as it reaches in terms of the concepts of face mask designs, decontamination, new processes, and the idea of digitalization is going to be exceptionally important in the context here as well, because there's a huge amount of data being generated in real time. There is a vast amount, and I'm going through that as well, in terms of all the factors where a lot of these devices are clinical, and basically it tends to be randomized controlled studies over a continuous period. So it's the idea of actually capturing that information for change. So I'm going to talk about some of the positional papers I've published in Science and the Environment. Just in terms of my own background here is, it'll be microbiology, toxicology. I did my PhD back in the late 80s, combining microbiology with high voltage engineering, as you do. So the idea of developing new technologies, and so I'm going to start here. So I'm going to use this as an opportunity to help by way, because I also see that this Empower Echo platform is going to feature hopefully strongly in our Run EU network among our family of partners now. So I'll just say climate change, the science is unequivocal. This is on basically in terms of Paris Accord, in terms of we're showing that we're going to look at seismic changes and the effects of increases in temperature due to obviously CO2 emission and temperature rises. And I'm going to give an example of this where I can see this on the ground in aquaculture related to other things as well. So that's important there. Just in terms of why I'm looking at the peatlands, okay, there's basically in the Irish Midlands we actually have a peatlands and it's bog peatlands, but basically it's a wonderful carbon sink, and it's across Europe as well. So basically you can store 1.4 trillion tons of carbon equivalent in the peatlands. The water quality is very high because it tends not to be captured or related to lakes and stuff, and because it tends to be standalone in its own right. So here there's an opportunity to look at harnessing I suppose the carbon sequestration of the peatlands with the development of new innovation in terms of wet-based processes such as I'm going to say aquaculture, but also bioplastics, with the view where we can measure carbon emissions. We can use even Copernicus and certain like satellites in terms of what we're looking at, and drones and doing this. In other words, this is a process where we're putting in test beds across the Midlands with a hub in the central location, connecting seamlessly with each other with the view of developing innovation and looking at carbon emission related to other activities. And this would allow us to look at developing new innovations in terms of bioplastics, I said, in terms of the face mask. But it is complex because I'd like to add to the story in terms of the manufacturing of these devices. So it's an eco-innovation hub unlocking the power of the Midlands and the peatlands. It's establishing, it's probably the first of its time in the Irish Midlands in terms of the peatlands. The reason why we're looking at that, because it's unspoiled, natural, and also there's a requirement. If we look at the Irish peatlands, were typically was 80,000 hectares. They were reliant of harvesting peatlands for burning in power stations. Now that has now converted to wind turbines, solar power, and also the peatlands. So it's a good opportunity of looking at that in terms of so in the context of this, we're developing, the goal is to mobilize the next generation of innovators, leaders, entrepreneurs from right across the Midlands. So we've actually done that, and I'll show you how we did it. But the transition to low carbon for Europe is going to be messy. There is no structure approach. So in the context there, we need to understand what's involved in there in terms of the key actors for change and how that's going to inform manufacturing as well in terms of the process. So in the context here, we've created living labs in basically one central location, which is a heritage site in the middle of the peatlands, and that's basically its social enterprise, fitted out reactors, etc., for applied work. And they're connected seamlessly to test beds across the Midlands. It'll be aquaculture, agroforestry in terms of testing, so we could look at new innovations. And that would be like life cycle assessment, ecotoxicology, carbon sequestration, energy. So all that's done in sync. Now there is a big challenge, and this is where I'm going to be loving to talk to Jeffrey for the next number of years to see how we can capture all this data and actually make it realistically in real time, because there's some wonderful stuff coming off here, but the world of digital is going to be so important in terms of data, one-to-one monitoring, machine learning, AI, IoT, because there's a vast amount of data, and is also in the context here of the, in terms of the interventions for COVID as well. So there's a growing opportunity. The point I'm making here in this slide is, and you can read it, is that there's obviously a growing market for the green. It's going up to 28.9 billion by 2024, and the green economy is going to be massive. So I've been publishing extensively in this area. I'm now obviously guest editor of Current Opinion Science, Current Opinion Environmental Science and Health, which is a sister journal to Science and Total Environment, and I'm looking at the whole area of Green Deal innovation for a special issue later this summer. So the companies are trying to look at in their carbon footprint, let it be from social responsibility right through to developing green-based, eco-based products, but it's how you actually develop and test them, and maybe link them to technology readiness level. And that's going to be important as well, from concept to near to market, and how you test that, and what level of carbon saving or eco-innovation design can be put on that. So basically it's driving climate change from a degradation perspective. There's efforts there to look at moving towards greenhouse gas emission reductions. There's a European Green Deal that's now vast in terms of the funding again, but there's no dress rehearsal on this and how this is moving forward, because there's nothing to base it off in terms of safe and just transitioning. There's circularity, and that's the context of what we're talking about today. Just in terms of face masks, which is important to see, obviously in terms of new design, having done this because I spent so many years, 30 years in sterilization, reprocessing, high voltage, etc., let it be from vaporized hydrogen peroxide, gamma, E-beam. I've done all those areas, and I've actually advised a lot of companies in that area. So if you're looking at new technologies, the material has to be sterilizable. It has to be treated. You need to work it in terms of filtration. You need to look at it in terms of material compatibility. You need to look at pressure drops, and then you also look at filtration efficacy as well. So you're putting those materials. Remember, if you're looking at face masks, etc., as well, in terms of these materials coming through, they are by design in their very nature, they're single use, and it is presented, and there's huge reliability on those that have been approved. So it's a regulatory market that's also need to follow in terms of these core criteria. So in terms of I'm just saying that there's a real requirement for a digital hub. And again, the point here is that recovering from COVID-19 requires and presents wonderful opportunities in terms of supply chain, e-health, because there's a greater focus now on addressing climate action in the context of the lived and shared experience that we have actually and are going through at this time. And I'll give you some examples of this in the world. So basically, let it be from point of consumption and waste right through to loss of animals. So there has been sequential lockdowns which are related to using non-pharmaceutical interventions, which I will talk about, and that's in the context of vaccines as well. But as we go through a pandemic, the level of people affected by that tends to go up exponentially because of the number affected with the R value, and I'll talk about modeling as well. So that's important in terms of that. Okay, so in terms of the transitioning, I'm talking about Bord and Mona. The point here, I'm going to move on a bit through this as well. The peatlands is a wonderful opportunity to look at this because it's natural resources. So basically, this is a multi-actor hub, which is Empire Echo. It's actually got 3 academic institutions connectively in terms of training linked to technology gateways, which would be enterprise. So we actually have 3 leading enterprise or I suppose innovation research institutes and enterprise linked to these academic institutions as well. So collectively, we deal with up to 300 companies a year in terms of sustainable, from digital right through to agri-food. So they're all connected with this. We have Bord and Mona, which is the main provider in terms of peatland in Ireland, which is 80,000 hectare, and they're now transitioning to climate solutions, and they're doing a really good job on this as well. So we've got local county councils in terms of government. We actually have local enterprises, we actually have private, and we actually got community groups. So it's the idea there is actually it's a fully network system. The multi-actor hub, to inform this, was I was coordinating, leading transaction modeling was very important. So I looked at all the factors associated with how universities link in with local communities and also with entrepreneurs and industries going back to 2000. Quite a while back, it was 2010 to 2013. So we used a transaction model to look to see where the multi-actor hub is, and that was a shared biotech project, and these are technology core facilities, and ultimately it's how companies and universities work together in terms of social enterprise and engagement across Europe, and to model that. And so I put in the main currencies, I suppose, the outputs of those to generate that. The other, it's an on-project, so I do a lot of transnational modeling for a lot of projects, and I look at the key indicators for climate change and what are the main currencies affecting the outputs of multi-actors in terms of affecting change. That's another one as well. I looked at all of the Interreg projects that are there based on wet innovation to see what's coming through there in terms of where this innovation is going to come from in yet maintaining carbon sequestration. So there's a number of these as well. So there's a lot of innovation interest in carbon because the peatlands combine carbon. So what I'm coming at here is that you can produce a lot of products and a lot of processes such as freshwater aquaculture, where you're getting vast volumes of algae, and you can use those for quite interesting bioplastics, or you can even gluten in terms of in terms of raw materials. I've also looked at transnational modelling, and I've done all Ireland workshops as well with all the industries. So I've asked them repeatedly what they thought about in terms of the new innovations to drive test beds across. The reason why this is important is that academics like myself often made assumptions as what I thought people need, as opposed to actually asking them what they need. So in terms of social change and going back, so I've actually gone and chatted to everyone. So Empower Echo is actually, this is a region of Ireland. So what we actually have done is I have mapped and collaborated with all the key actors from local communities right through to food hubs, right through to innovative campuses. We're at Lone Institute of Technology would be central place, and that's in biopractice, so in terms of processing. So what we have done is established an ecosystem where they're all connected, and by way of facilitating through this test bed, in which is the main central point in terms, with the idea of accelerating green innovation or green enterprises. So this structure that I'm setting up is by way of testing, and also looking at, I suppose, aligning it with eco-design, eco-label, carbon energies, carbon sequestration, right through to right from concept to the higher TRLs. The other thing which I do with this is I have a number of Marie Curie Rise funded Interreg projects. They're all successful. So I have been sending a number of companies across Europe being trained in this core area, and where they're coming back as well. So I would have a large number of H2020 Interreg and other projects funded in this area. So the idea comes entrepreneurial hub, research is moving forward, there's education. So my point here is that there's ecosystems in the row. One is an entrepreneurial hub where you're looking at developing this accelerator, which from a bottom perspective, that actually is then informs research performing exercises at the test beds. Which is really important then is the education linked training to the academic institutions in terms of sustainability for communities. And that includes Industry 4.0, digitization, agri-processes, because the idea is a loop. You need to actually be looking at both education, training, community transitioning, and then funny enough, research performing is actually the tail end of it, because research is carried out having met or looked at the needs of communities to see what they require. So research will actually inform what the goal is, and this is what this product is about. So it's incubators. I just want to say it's intensive incubation, soft landing. So that's what we've been doing. It's providing a central, so basically the Empower Echo is a multi-actor hub, as I said. It's providing a central facility at a place called Lochbora, which is a heritage site in the centre of Ireland. And basically it combines academics, industries, and all the actors under the one hub for social change, including social enterprise, with the view of social marketing to see what needs to be done. That will then inform startups, but we need some more testing to do this. So in terms of that, it's digitized. So a lot of data is coming off this. When we're early phasing the data, this is where I'm looking forward to linking, particularly with my partners under the Run EU across Europe. So that's a building, that's 20,000 square feet, that's dedicated there, and that's been upgraded at the moment for social enterprise and all of the reactors, etc. So social enterprise from that off the peatland would be bellheader honey, exotic mushrooms. It's going to develop, we've already linked with all the companies to look at new scale-ups, SMEs. Number of people is 1,500 are going to be trained in these new areas. A number of them will be unemployed or seeking employment from COVID, and then rediverting them to low carbon. And I'll give you an example of some of the areas we're working on. That's a mind map initial going back to February of the last year. So in COVID, which is nice to say, this hub arrived in the middle of a pandemic, and at the same time I was looking at other things for masks and everything else. So these are typical activity: concept design, access test beds, access equipment, access platform, access monitoring. This is a very crude slide. Office space. So this is what's happening at the moment in terms of hot testing and bringing people in terms of skill nets. These are the areas that are all connecting it as well, because they're all interfacing, including energy, digital. So some of these are more advanced than others in terms of climate proofing relates to some of the test beds. So introduction to hub experts, digital nomads. So these are typical activities that would be facilitated or being advanced at the moment. So at the moment, I've been awarded 1.3 million with the 1.3 million euros from the local Just Transition in this area. This is connecting with other projects across here to the value of 29 million euros in terms of facilitating this from a regional perspective. So what I did is, what I published in the Science and Total Environment is I actually have published a number of papers recently. These are typical factors that are relevant in terms of, and that would be important for RunEU, typical things: step change physical infrastructure, pre-startups. So in other words, if you have a multi-actor hub with the academics linked to the environment and to industry, these are desirable things in terms of what people would need to be seen in terms of outward activities linked to key core activities, design maturation, technical financing. So a lot of this in terms of my transnational modeling will also show that the idea of designated industry people for training, knowledge transfer, interface, and their sustainability, long-term sustainability is important in terms of training. And I'll show you some. So what I also did as well, Ireland runs has run two disruptive technology calls. In other words, what new bright ideas are coming through in ICT, manufacturing, health and well-being. So of that, there was two big calls under disruptive innovation. So you like what I'm showing here, which I've published in this recently, so you can actually source that with a full review of it. These are the areas that Ireland actually, in other words, an open call where people, and these are ones that have been food. So the health and well-being in terms of numbers, you can actually see 40 applications have gone where people thought in Ireland that you're going to get disruption of those areas. The other immersion was coming after that would be 20 projects or cross-cutting project with ICT. Often though, what I'm looking at, which is a challenge for Europe and as a challenge for Ireland, is that often these projects are seen as standalone and not aggregated or cross-cutting. So if you look at the food, it was seen as one or two, but actually when I looked at that, food would have cross-cut 16 of those projects if you actually look at the scope of it, but it wasn't done. So the value here, so where I saw this with the new hub is that I see disruption across food, ICT in these aggregated area, which isn't fully appreciated with the idea of sustainability. So these are valued, these were funded up to 250 million in the last 2 or 3 calls. So there is a real importance for embracing ICT and manufacturing to facilitate those areas, okay? So MPRX, I look at a number of areas. I'm looking at peatlands, agroforestry, pollination, seafood, with the consortium people there across Athlone Institute of Technology, Limerick, and will be with the RunEU partners as well. For example, I am actually developing, this is 6 hectares of freshwater aquaculture. This is taken from a drone, and this is fully recirculated freshwater aquaculture that's producing trout and perch. It's fired by wind turbines. It's totally organic. It's based on duckweed. It's based on algae, and it's also based on bacteria for pure water regeneration. So there's no antibiotics. We're producing vast amount of fish, and it's and there is no pollutants. So in other words, there's no pollutants going to the receiving water. So there's vast volumes of algae produced there that can be used for bioplastics. What's beautiful about this is that there is, in terms of no carbon, in terms of, because it's a wettable technology, and there's recirculating, so you're not discharged into the environment either. So this is the first European model using the peatland of fully sustainable food in terms of freshwater aquaculture production in the peatlands. The challenge here, guys, is that when I've gone and presented at international conferences, I was advised that end-of-pipe solutions such as advanced oxidative systems and technology such as pulsed UV is not, because you're producing obviously potential pollutants to the environment. We have had 3 storms on that site due to climate change. And what has happened there is, because of the constant storms and rain levels, it threw off the microalgae to produce cyanobacteria, and we had fish deaths. So the point here is that climate change is major, even in a closed system. But what's beautiful about this system for sustainable manufacturing by their byprocess and by the byproducts and waste, we can produce a lot of bioplastics from this natural system, yet produce fish. And then you can put that through other process. So if you look at this from a process, and if you get an idea of data, and I can talk then about Industry 4.0 on face masks as well. So here's an example where on the top right-hand corner, basically it's a fish pond, and we take out fish. Basically on the left-hand side, on the top is physical measurement, physicochemical measurement over at least 16 parameters, handheld on the lab, doing all those, and then doing PCA analysis, which takes age. In other words, what is the pH, what's the temperature and all that. We do that every week, every day, and it's really difficult. So what we're also doing now as well, the bottom left end is a thing called flow cytometry. We can do 10,000 reads per second in the living lab and detect all of these parameters in real time in data. And then the bottom right hand, we can have a handheld torch in the aquaculture, which is measuring these things in real time. So what I'm now doing at the moment is trying to connect through data, the living data in the lab with what's happening in the farm, with the view that rather than waiting for 2 or 3 days for data, we can then give data immediately back under, let it be under a mobile phone app or by machine learning under sensor. All that data is there, and that's going to be really important for sustainability. Again, I'm looking at the plants in agroforestry. The reason why I'm saying this, the forestry is relevant as well because of carbon and carbon emissions in terms of processes. So digital heritage is going to be important as well, because once that's in and the systems are connected, it's a natural based system. And so therefore for walks, recovery, mental health, these ideas for people recovering from in the long term in terms of having these natural walks is going to be very important in terms of social engagement. Equally, what we're doing at the same time, we're looking at renewable energy sources from connecting the wind turbines right through to energy assessments, climate action. We're looking at CO2 emissions, we're looking at carbon sinking. So as we're developing a technology for eco-design and labeling, we're also looking at CO2 emission footprint in terms of these processes in the area. So just safe and just transition, what we've actually worked at, and this is the NESC, and I've just taken some information from their national slides here, is that extended supports are required in terms of building resilient enterprises for people, including manufacturing from SME. So you need boot camps, you need booster awareness and take up, you need to look at funding models, you need to look at early movers in terms of how you would actually support them. In terms of continuous preemptive workforce employment, we need to look at increased ambition. So projects like this are really important because you need to be ambitious and bold to come out of COVID. You need to be, rather than being recessive, you need to grab it, run with it and invest in it and be ambitious. So this is what we're doing in Ireland, and we're going to be trying to be as ambitious as hell to try and get through. So it's increased ambition through improved resources, higher targets, incentivize employers. So increase information in terms of audits. So why I'm saying this is that you're getting the small to the large manufacturers as well as those in agriculture and actually supporting them from a bottom-up perspective, because that will actually then speak to low carbon. So you can actually reach out to communities there in the role, including social change. Delivering high impact funding. Again, I've been actually helping lots of communities in terms of writing grants. I actually help with H2020 grant writing. I've actually helped companies write SMEs in terms of innovation actions. So, and they actually, in terms of both secondments, like the Marie Curie Rise, we have 217 secondments into Ireland and out again under training, under manufacturing, etc. They're on hold until September. But basically the idea is that they're going to get trained in other areas and then come back and bring in employment there as well. The funded application, local plan development, more place schemes, better engagement. Okay, I'm just going to talk a bit more. So in the last couple of slides, and I work on this one over a number of slides, is it highlights that there's now a new eco-hub innovation to capture the emergence of bio-based products that we can then recirculate into new products in terms of testing by way of giving it to some level, either pilot scale or validation with a process. Fine. So the next thing in terms of my interest in COVID is that I'm just using this as an example in terms of the themes that are coming through this wonderful seminar series. And that would be, if you're using, say, a plastic or a bio-based plastic that's in a face mask, and looking to see what would be involved in those areas, and just by my own background. Okay, so I would have done a lot in this area. So I have 30 years of sterilization technology and also bioprocessing, microbiology, parasitology. So I'll give you an example how the madness of the pandemic has kicked in. Okay, back in April 2020, I had a chat with the editors of Applied Environmental Microbiology because of my concern over COVID in terms of sterilization, lack of face masks. So in the context here, I had a good understanding of virology from the lower. If you look at the pyramid, you're looking at envelope viruses, which is COVID. So although they're extremely transmissible and they're infectious, their nature, because they're enveloped, they're highly susceptible to biocides and to physical technologies. So in other words, you don't need a lot of a biocide to address it. So what I've done there is typically with an indicator for the manufacturing of original equipment manufacturers for devices and look at masks, etc. They're looking at 12D reduction of bacterial endospores. You don't need as much of that if you're looking at a very soft virus. So what we looked at there in that was, in other words, so at the time, there was only about maybe 6 or 7 publications in the area on sterilization and masks. So what I've advocated there is maybe vaporized hydrogen peroxide. So that was a paper there, and I bring your attention to the bottom corner. I did chat with the editors, so I conceived the paper and wrote it on the 4th of April. It was received on the 5th of April. It was accepted on the 5th of April, and it went online on the 6th of April. And it now informed vaporized hydrogen peroxide pulse UV, and has now got 116 citation in the impact 6.5. In other words, there was a requirement for urgency to get things done, and that's a typical example there. So what I've done there, guys, is that I've just published recently in Science Total. I've looked at all of the factors that would affect cycle of infection where face masks would need to be considered. Reservoir, portal of exit, mode of transition, portal, and that's just been published 2 days ago in Science of the Total Environment. In other words, these are all factors that are important that need to be controlled or considered in terms of mitigation factors. Face masks are going to be very important as an intervention strategy, but it needs to be considered in the context of other user non-pharmaceutical interventions, because we're going to be working with this for quite a long time, and vaccines are going to be very, very helpful, but you're going to need to work with these for quite a while. So the likelihood is that if you look at the infectious agent, viral load, virulence, the variants are going to be interesting, but the virus itself, it's typically a mutation in the spike protein, which is transmissibility and pathogenicity. So in terms, but it's still 60 to 120 nanometers in diameter. It's still an envelope virus. So the likelihood is its same filtration efficiency or same bioefficacy will be applied in terms of efficacy. So in terms of that, that's important. So in terms of this, what I also looked at there is Science of Total Environment is that I looked at the use of this peatland model in terms of looking at the develop of disruptive innovation in these areas. And I contact with in the area, particularly the food, and that was published there. And that actually showed that there's drivers for change, there's lockdowns, but there's a balance there. But also the main core is actually to keep your health service in terms of frontline and those and the R value low. The other, in order to drive innovation in these areas and also support. So I've got that delineated in terms of cost analysis, risk mitigation in that paper that has been published there. And I think it's the first, it's published recently, and I think there's about 20 citations on that in terms of using typically peatland as a model. The other paper that's just after been published in the last couple of days is, I looked at all disposable designs, the 3 phases. I know there's talk there about the hot melt and spin burn in terms of the various stages. And so I looked at the whole innovation there, but I also looked at in terms of innovation, in terms of design model and mathematical model in the context of control studies. So that's just gone out in terms of there is a pressing need to look at alternatives to plastic for single uses, because it's a growing waste, clinical waste for the environment. However, it's a very regulated industry, and for a good reason. So therefore the requirement, for example, I've actually worked with companies in the past where they're looking at sterilization, and you could spend 1-point-something million on new product and then find you can't sterilize it. So therefore you need to look at the whole thing at the starting point there. So the challenge at the outset was there was in 2020, there was only a handful of publications, everyone's scrambling. So everybody is now scrambling for reliable data in a pandemic when there isn't information to be got. So, so open access is really important. So in certain areas alone, you're having up to 20,000 publications in the space of X number of months in a course area. So the challenge here is that because these are clinical devices, normally it's a longitudinal study, randomized control over several months to look at these. So now we're looking at trying to look at best data for these situations based on probability. So the point I'm making here is that as data becomes more available for clinical randomized controls, the idea of digital and using end-to-end monitoring, looking at the sensors, looking at information and linking to risk modeling is going to be very important. So therefore the pressure points, and to conclude, is that supply chain of PPE is going to be very important, and actually understanding that as we move forward, because we still will be living with COVID for a while, and manufacturing is going to be exceptionally important. However, if we look at PPE, which is discussed, it is designed typically for single use. The plastic is a problem, but we still need to make sure that we match filtration, decontamination, pressure drops for these things, for those standards. Single use PPE is a major problem, no doubt. And the idea of upcycling, recycling is going to be important. New design innovations are going to be very, including coverings will be important. There's people looking, as you're saying, there's carbohydrates, phenols, there's glutens, etc. They need to be, but they need to be tightly regulated, the FDA, and also at those areas too. Sustainable food supplies, waste mitigation, life cycle assessment is going to be very important in terms of those areas. Mathematical model, which I've looked at all the mathematical models, and we looked at simulations and we looked at predictions, and they're basically but again, if we look at what were the intervention strategies, it's all based on risk. If you look at a filter and face piece, you look at N95s, you're looking at still 95% efficiency. If you're looking at face masks or face coverings, it's less. So it's about reducing risk in terms of the mitigation. So the variants coming through, the likelihood is by increasing the filtration efficiency, such as this, I know we mentioned electrospinning and all those things would be very good. You are reducing the likelihood of transmissibility because you're retaining and or doing other things with the mask. But the idea of modeling is going to be very important. It needs to be linked back to other control factors as well. So ultimately, the challenge here is that all these things slightly change. If you look at FDA, etc., which are wonderful, is that there's design changes as we go, and other people are looking at other things as well, and we're looking at non-pharmaceutical interventions, whether it be social distancing, etc. There needs to be some IT systems to improve the EU preparedness in response to future pandemic. We need to look across borders to inform common and consistent policies on this, with the view of these interventions. And what is really important in this is also climate and waste, and the growing number of, as you said, single-use plastic face masks by way, or PPE. Just in terms of the sterilization, and then it's basically like, if you're looking at sterilization, like vaporized hydrogen product and heat, and obviously the other thing that I suggested was UV because of the material compatibility. But in the context there, the reason what it was is that these are soft technologies in terms of reprocessing, as opposed, and that aligns with material compatibility. So the reason why vaporized hydrogen peroxide was taken over gamma and other things is that the materials would lend themselves typically to under emergency use reprocessing. Typically under other things, because they're designed as such and regulated, it's for single use typically. And I also just hand out to the original manufacturers of devices, it has been really challenging, and they've been very helpful in forthcoming with the information from a regulatory perspective. But as we move forward with designs in this respect, I think there's also, in terms of testing, let it be viral loads right through to chemical indicators of that, in terms of standardization with these processes. But it is no doubt to avoid future plastic waste and etc. The area waste mass is going to be very important. So industry is going to be important, and that's just an overview, and I thank you for your time.
Right, thank you very, very much. A very impressive lecture. Now we have a few minutes for questions and discussion, and I wonder if perhaps I could start by saying, I think one of the common themes that comes out from it all as a sort of, as an educationalist, is that what we require people to have is a very broad base of knowledge, because it's a very interdisciplinary area, but to have some deep knowledge in some very specific areas where real expertise is required. And I'm thinking if you've, I know that there's been some developments in Ireland in the education system in terms of new institutions and such things. I just wondered if you had any thoughts about the educational process to achieve that, because in a sense, I think you're probably a very unusual person that has a broad breadth of knowledge, because you've developed a number of experiences and you have some knowledge in depth, and it's sort of how to help other people to achieve that same sort of a bucket of skills and expertise.
Yeah, Jeff, I agree. I also appreciate it is unusual in my background. I've had been the experience of actually moving across so many domains and disciplines, but I think I'll answer that question of two ways, if I may, Jeff. Firstly is basically there is huge benefits of aggregating or cross-cutting disciplines in terms of added value, and particularly such as the humanities and the science and social area in terms of social change. Because ultimately, if I'm looking at these tech, and this is what I've sit on the faculty of science, humanities and business as well. So the idea, and so therefore, the new institutions are trying to promote cross-cutting or interdisciplinarity in those areas. So in other words, social change, social marketing, and acceptability. So in other words, if we're looking at these new innovation, new designs in terms of these are a little value unless you know they're going to actually be used, or if there's actually pressure, if there's going to be pressure points. And so basically that's, so the other side is, that's, it's all in terms of the marketable uptake and how it's been sold and how people can change. Because ultimately, I could turn around here, and one thing I've noticed, I deployed with all of the clinics vaporized hydrogen peroxide and VUB, and I showed it. I said, it's not used. Why is it not used, Jeffrey? Because the nurses have no confidence and don't understand the process, that they may be getting inferior devices that no one actually has proven to them from a behavioral perspective that they work, and they're in the front line and they're not going to take. So in other words, there is a lack of educational literacy, and I don't mean that from a disrespect, but in terms of educating frontline people that they are effective and you need to use them, as opposed to buying stuff that comes off the shelf. So that's really important. So we, apart from StarMed hoods and ICU, others were not used. So the idea is that we're moving away from, so I think it's important, and that Europe is doing that as well, and then bringing in key people across a number of domains. The word is kind of silo, so you're moving away from a silo to a cross-cutting one where you're bringing enterprise in to actually help that. So the education system in Ireland is progressing that way towards likely cross-cutting projects. The Run EU is actually a perfect example of that, where you're actually, but the big thing is that if there is a pressure point, for example, as I said, if I'm developing a technology, let it be vaporized hydrogen peroxide, and I've got a new design, if I'm looking electrospinning, etc., then find that's all good and well, but you know what? It'll never go through either an X-ray or a vaporized hydrogen peroxide, because it can't desterilize it for that application, so it's useless. So I think early phase SWOT analysis of key using this approach in terms of funnel is going to be very important, because what happens then is that you can actually gauge for risks early and actually help people in their design by bringing a lot of the actors together at the one time. And that includes marketing and social marketing. And I think, so the education system's gone, I agree, but you also need someone, one or two, particularly in key areas that would have a good level of and bring in industry as well on a early stage. So the first thing you do is bring the sterilization industries in on a regular basis. So industry and that engagement and entrepreneurs is gone. I hope I've addressed your question, Jeff.
Yes. I mean, I think you're focusing on particularly how to solve the current situation, whereas I was thinking of how we build into the education system the ability to be able to cope and respond to pandemics or other similar situations in the future. And I was thinking that obviously one of the characteristics of nearly all education systems is it's very much focused on to the early years. I mean, early years as in up to 25, as against providing a continual education, as many people say, but actually, in fact, relatively few people do, and there's relatively little reward for doing this. And
Jeffrey, you're right. I think it's getting towards, I suppose, from an Athlone Institute of Technology perspective, we're enriched by the fact that we're linked with research institute and gateways that are dealing with industries at a very advanced level of engagement for basically new technologies and new. So in other words, industry at a very advanced level, at a very applied level, is ingrained across. So it's not only theoretical, but it's very much applied, where people are, in other words, you're actually getting frontline problems where industries are coming in, and that's been fed into the institutional perspective in terms of that. So in training. So where that is coming from, moving away from classical systems, is that you're actually getting more entrepreneurial and enterprise moving into theoretical information in real time, linked to taught masters and PhD programs.
Yes. Yeah, okay. Thank you very much. Any other questions or comments? Joanna, you look like you're phrasing a question.
Shall I run now? I think, Joanna, you're on mute.
You're on mute. So
now we're good. Now we're good. Yes.
Just to congratulate the work. Very interesting.
Thank you.
Appreciate it.
Yeah. I suppose over the number of years, because I've been in lots of universities and well, in terms of the mobility, but I see the aggregation, or people come together from a number of disciplines to tackle complex problems as a team, has been really, really, really important. But as Jeffrey rightly had indicated, like, if there's a core pressure point in the project, you do rely on, early phase with a number of expertise in that area. But I think that there's going to be huge opportunities to integrate the social sciences with the STEM in order to address problems, because in order for that to happen, you need to understand how people change from a social perspective to actually bring in these. But the other, I suppose, on a regular basis, the technologies are there and we're evolving very quickly in terms of addressing it. And it's I think the fact that we can talk about electrospinning and 3D printing and all these wonderful things in manufacturing, where we didn't have that maybe 10 years ago in terms of addressing problems, is phenomenal. But I think the ICT, machine learning, like what I'm actually doing now, I've actually gave a talk in sterilization industry, and but where we actually used augmented reality quality of experience to show how pulse UV is delivered to, in other words, I think that's going to be so important. Remote learning, that's something we've just under this pandemic. So the idea of using augmented reality, virtual reality for training, and having that for Erasmus and other training, so people will see things early from an educational perspective, is going to be very important. So industry, digital, quality of experience, AR, VR, linked back to STEM, is a huge step forward for everybody, and that in terms the modeling as well. I think that will be very important. And that's a picture of a bumblebee, because I have a project on bumblebees as well, because I'm looking at sterilization or trying to get rid of the parasites in there. So it's quite nice that you get and then you can get honey as well, which is great. That's a product as well as we go.
Yes. I think your comments about augmented reality and such things are are very pertinent. As perhaps you recall, in May we're organising an international conference which is on direct digital manufacturing and polymers. And yesterday the organising committee met to discuss this, and we will have an exhibition which we hope will be presential for people in Marina Grande and elsewhere to learn about these new technologies. But of course, we have all of these other technologies in which we can take that physical representation and turn it into something that can be online. And but also thinking in terms of the conference, that how, you know, like today, it's a very sort of conventional experience, and whereas we could be having a glimpse into laboratories, or looking at results, or looking at activities in a completely different way, rather than as a in a PowerPoint presentation, and I think this is where, in a sense, I come back to the observation that we all need a very broad-based education, but we need real skills in particular places, and it's how to marry those things together. Otherwise, you end up with some sort of experts that are in the back room that do all of the fancy things, but where none of us really understand the real scope of these things.
Yeah, I've looked at projects that are all from science and technology and a number of the areas in terms of humanities and I suppose the digital area as well. And one quite nice example in terms of an Interreg and other projects is that you might have a multiple locations across Europe doing different things, let it be from genomic sequencing, benign sequencing, right through to augmented reality. So what we actually have is a laboratory there, which is under digital twin. It's it's captured visually in terms of AR, VR, and then that's stacked in the one building virtually. So all of the areas are actually in the one building connected to each other virtually. And you can actually see the seamless integration of these activities, although in different location, in the one building. And then you can get AR, VR looking at in terms of those. So you can do a walkthrough in there. And what's nice about that is if there's someone from Erasmus coming in advance of them or whatever, they can actually go through that virtual experience of those areas and see how they're connected, and even to see what areas they may want to spend more time in based on the level of interest virtually. And that doesn't also, I suppose, it also, AR, VR is also particularly going to help in terms of high risk areas where other people can't go manually or would not like to go manually. So that will allow for the area of de-risking there as well. So education, training, research in that loop leading into innovation and enterprise is a common loop now for everybody, linked back to academic excellence.
Okay, thank you. Well, perhaps now we should move on to the last phase of our program this afternoon. Thank you very much, Neil, for
our pleasure, everybody, and I thank you for your time.
Yeah, you've encompassed nearly everything in the world that we need to think about, and now
there's a multiple choice and it's negative marking. Okay.
And we're moving on to Artur, who will provide a summary of our experience today.
Okay. So I have here some notes. Let's see where I have. Okay. So this is I organize here a summary for the International Manufacturing Forum series of this second edition in February. So this is the second edition of the International Manufacturing Series dedicated to COVID and manufacturing. We had the participation of 7 speakers, if I'm right, from areas of bioengineering, biomaterials, manufacturing, and engineering management, physics and chemistry, An introduction and welcome was made by the President of Polytechnic of Leiria, who underlined the importance of these sessions that are open access, and by that way allow the society, companies and other entities, individuals to have access to the contents of interest in order to apply them, extend them, and for a better society growing. We had presentations focused on the production of products with high filtration level through the application of several materials, some alternatives to the polymers usually used, and non-usual manufacturing processes. Some of presentations are focused on sterilization and cleaning surfaces, and others in the development of active materials focused to inactivating virus and reducing material action of surfaces and products. In this atypical period of pandemic, we found that we all had to reinvent ourselves in order to continue our life, work, and interaction in some way. As in the case of this conference, discussion forum, now possible via the internet, industrial companies and other organizations must also be prepared to achieve levels of flexibility that allow for quick adaptations. In this case, we talk about the technologies of augmented reality, virtual reality, digital twins, collaborative robotics. In this way, as Charles Darwin said, it is not the strongest that survives, nor the most intelligent, but the one that best adapts to changes. This theme, COVID-19, also highlighted the issues related to the circularity of the economy and the importance of a transition to a low-carbon economy. Several interesting works are then presented by our invited speakers, and we believe that this forum was allow and will allow, given its virtual concept, it's eternal, that many curious, interested individuals, entrepreneurs, researchers, among others, find solutions to the challenge raised every day. This is a general summary of all the forum. Of course, a lot of details could be discussed for each subject presented. As I mentioned, the virtual concept is a forum that allows the future to be detailed, or a detailed view in the future of a particular presentation. So finally, we thank the generosity of our invited speakers who came to this common virtual space, share their knowledge and experience in these topics that are so important these days. We would like to thank to Dr. Patel, Dr. Tariq, Dr. Joana Valente, Dr. Estelinha Silva, Dr. Filippo Pierini, Dr. Joana Curto, Dr. Neil, and finally the whole audience and also the members of CDRSP, especially those who have making these forums possible. By the end, we invite all to the next session that will be in Forum March about food and digital manufacturing. Thank you all. I think that this is more or less a summary, a general summary. I could share, I have it in a PDF file, so I could share to the audience.
Okay, thank you very much, Artur. I would just add my thanks to Renato and Thomas for dealing with making this virtual space possible.
You're welcome.
And
many thanks to
as Artur has done, to draw your attention to 1 month from now, another exciting way to spend the day. Hopefully, maybe not in lockdown, but because it's a good way of making progress. We have the March edition on food and digital manufacturing. And I also remind you that this is a never-ending conference. So there's a session every month. And in May, we will be organizing a 3-day conference on direct digital manufacturing and polymers. and which we're now open for submission of abstracts, as with all of the other topics. So thank you very much. Thank you for being here. Thanks for the questions and comments. And we look forward to seeing you another day in the future, maybe even in reality. Yes.
Bye. Thank you.
Thank you. Okay.
Thanks, Jeffrey. Thanks,
Yeah.
Arthur.
Right.
Yeah.
Bye-bye.
Bye-bye.
Thanks.
Bye-bye.